Good morning, all. We'll begin the session in a few minutes.
Madam, speaker connect ಆಗಿದ್ದಾರಾ?
Sir, yes, she has just joined, sir.
Okay, madam.
Yeah, I'll just start, sir. A very good morning and a hearty welcome to day 2 of the 3 days conference on applications of artificial intelligence and computational mathematics 2020 on the virtual mode. We have today in the technical sessions a keynote talk by Nimisha Sharat Sharma. Ms. Nimisha will be talking on deep learning models in production, a study of personalized recommendation systems. Ms. Nimisha Sharat Sharma is data and applied scientist, Microsoft, Seattle, USA. We'll have, after Nimisha's talk, at 10:30 a.m., Dr. Mathirajan M's talk on a machine learning algorithm for scheduling a burn-in-oven problem. He's a professor in the Department of Management Studies, IISc Bangalore. Followed by Dr. Mathirajan's talk, we have with us Shri Ms. P.G. Bhatt, founder and director, Pluma Knowledge and Solutions Private Limited, Bangalore. He'll be talking on census and sensibility. After these 3 sessions, we'll have our regular presentation tracks from 2 p.m. onwards. So let's begin the day with invocation by Professor Suma from Department of Mathematics. Thank you, Suma and team, for that melodious song. On this beautiful day here in Bangalore, the song definitely added to the beauty of the day. So we have here Miss Nimisha Sharma joining us all the way from Seattle, US. In spite of the time difference, she has obliged and to our request and has joined us here for a talk on data analytics. I now call upon Dr. Amuta S. from the from the Department of Computer Science and Engineering to introduce the speaker. Over to you, ma'am.
Yes, ma'am. So good morning, all. It's our privilege and pride to have Ms. Nimisha Sharath Sharma, data scientist, Microsoft Seattle, USA, as the speaker of today's morning. I feel happy to give a brief introduction about Ms. Nimisha. She completed her BTech Computer Science at NIT Surathkal, followed by her master's degree in data science from University of Washington, USA. She had associated herself with Carnegie Mellon University, USA and Concordia University, Canada for a couple of projects. She had also been the conference director for the Women in Data Science Seattle at the University of Washington campus. Ms. Nimisha was also honored with Indian Academy of Sciences Fellowship and MITech Global Link Fellowship to her credit. I request Ms. Nimisha, thanks for accepting our invitation, and we kindly request you to start the session. Thank you.
Hello, am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Firstly, thank you so much for the opportunity. It's my utmost pleasure to be presenting in this conference. Let me start the presentation today. I'll just share my screen. Please let me know if you're able to see it. Are you folks able to see my screen?
Yes, ma'am. Yes.
Okay, cool. Great. Good morning, everybody. I'm Nimisha. As the introduction was done, I work as a data scientist at Microsoft. And today I'll be talking to you all about deep learning models in production, a study of personalized recommendation systems. So the reason why I chose this topic was because I primarily work in the personalized recommendation space on Bing.com. For those of you who are unaware of Bing, it is the search engine that Microsoft has brought out. It's been around for about 10 years or so. Its primary market is US, so it's more popular in US and Canada markets. So it's primarily, I work on these sort of recommended for you trending products, these kind of carousels in Bing.com, which is counted as personalized recommendations. So I work on the data pipeline, feature engineering, model training, testing, deployment, and basically anything and everything to get these kind of carousels shipped and made more smarter. So let's look at the outline of today's talk. So I will specifically be speaking about two things. Firstly, the recommendation systems theory, which I want to introduce to you the aspect of deep learning and recommendation systems. And before I do that, I think it's a good idea to get to know what kind of recommendations were available to us in the past before deep learning came into establishment. And I'd also like to stress upon how these deep learning systems, which are part of personalized recommendation systems, are part of production scenarios in large companies where people, millions of people are served these kind of recommendations, and how it all comes together in production and what you see as a user. So first of all, what is a personalized recommendation system, right? So sometimes when you open websites such as Netflix or Amazon or Google and so on, you see carousels like this, inspired by your browsing, recommendations for you and so on. So how do they actually help if you think about it? It's basically a system which suggests items that could be useful to you. So instead of seeing just a static screen with something that is not relevant to you at all, Companies like Netflix, Google, Facebook, and so on invest millions of dollars in trying to make the experience more relevant to you as a user. Now, why is this important exactly? There are over 1 billion content-based websites in the world. And by content, I mean text. It could be images, it could be videos. Anything is content right now, anything that can be consumed online. So when the user has these many options, why will they stay dedicated to just one website, right? So as soon as you enter a particular website or any service, the user expects to be served exactly what he or she wants to see. So if they're not served that, then they just close the window and move to the next one, right? For example, if you're trying to look for a movie on Netflix and you don't find it, you close it and you just go to Amazon Prime because you have a lot of options. So it's very relevant to try to create a personalized recommendation system for companies today. In fact, it's not even something that is considered cool. It's something that is considered required. Otherwise, you lose a particular customer, right? Now, as I mentioned, it's all about the user's experience, right? Now, let's look at an example that I've pasted on this slide here. The topmost example is of a website which has static experience of sorts. So you enter the website and you see something like this. You have your usual, carousels. You see, okay, gifts for women, gifts for men, gifts for kids. It's all looking pretty good. However, I don't really know what I want to pick from here. I'm overwhelmed by the choices and I'm not really sure whether, where to start and so on. Whereas if you look at this snapshot, this is actually a snapshot of Google Shopping. Very recently, during Black Friday, which is a big thing here, I purchased an Amazon Kindle. And Google has able to capture that I was able to purchase this because I had been researching on the different versions of Kindle, and it is suggesting me an e-reader case. Now, I never thought of purchasing an e-reader case, but the fact that Google suggested it to me, and I'm seeing that there are several options, there are many prices, I might actually click on one and buy it, right? So this is the kind of experience that people want to converge to. And this is the kind of experience that we will learn more about going ahead in this presentation. Now, there are various kinds of recommendations in various kinds of websites, right? Now, let's look at this screen, for example. This is a very familiar screen. This is youtube.com. This is my youtube.com profile on which I have signed in. And I think I took this screenshot maybe a week ago when the US elections had just happened, a couple of weeks ago when the US elections had just happened. Now, as soon as you see this, this website, right, you don't immediately notice everything that is actually personalized. But if you start noticing the different aspects of the website, you start seeing that every small little thing is actually a very intelligent feature. Now, I've highlighted only some of them. Let's start from the top. So you can see that there are a couple of topics that have been suggested to me. Now, I know that my professional introduction had been done, but let me give you a slightly personal introduction of mine as well, so that whatever you're seeing is more relevant to what I'm saying. So I'm somebody who likes to grow plants. I like to cook. I look at a lot of interior designing because I try to make my apartment nicer and so on. And I also host a podcast. Now, all of these are features about me as a user. And YouTube has somehow been able to capture most of these things about me, which is interior design, podcast, and so on. And along with that, it's also suggesting that, hey, since you're interested in interior design, podcasts, maybe apartments and so on, maybe you're also going to be interested in gifts, in houseplants, and things like that. It's also able to pick up where I am, and it's suggesting, okay, the US elections just happened, so why don't you watch a couple of videos related to the US elections? So these are location-based recommendations. Similarly, it's also picked up on the fact that I watch this particular YouTuber's videos a lot. So this person's video has, reached the top slot in my recommendations. Each of these features are actually, a 10 or 20% team sitting and trying to make that particular feature smarter. And I say this from experience because I work on something called Recommended for You, and I myself work with 10 other people who try to make it all come together on Bing.com. One such feature that we worked on very recently was something like this. If you end up searching for a dress, right? It's possible that you're also trying to put together an entire outfit. So it makes sense to also suggest what goes well with the dress. So along with this item, another item is recommended. This again is another 15% team who's working on just creating this and making it smarter. So let's look at the different techniques in which a recommendation system can be created, now that we know what a recommendation system actually is or how it can be visualized, right? So let's go to the first one. It's called as collaborative filtering. This is one of the oldest ways to recommend something to a user, and there are various ways to do it. So let's look at the two most popular ways of doing it. So the first way is user-user, and the second one is user-item. So let's look at a scenario in which a user-user type of collaborative filtering would be useful. Let's say you want to, it's the weekend and you've had a long week, you want to watch a movie, right? But you don't have time to sit and research which movie to watch. So what you do, you quickly decide, okay, let me call a few of my friends, or let me text on certain WhatsApp groups, and let me ask them, hey, what kind of movies have you watched lately? Give me some suggestions. What did you watch? Which was good, and so on. And your friends give you a bunch of suggestions. And based on that, you do a little bit more research and you decide, okay, among all of these things, I'm going to select this movie and watch it. Now, there are multiple things at play here. Now, the first thing is you decided which group of people to consult. You didn't go ask your parents maybe, or you didn't go ask your grandparents. You went and asked maybe a group of friends, or you maybe asked 3 groups and took the average of all of their suggestions. The second thing what you did was, even though a bunch of your friends suggested multiple things, you picked whatever you wanted in that list. So even if 20 people suggested Inception to you, you probably didn't pick Inception at all because you already had watched it. You picked, I don't know, Lion King or something. So this is a classic example of a user-user recommendation system where you as a user, take multiple other users' feedback and take a decision based on that. Now, as a company, for example, Netflix, they don't know who your friends are. They can't really build any sort of connection between you and other people because they don't have a social network in play. So how do they simulate this, right? So how Netflix or other companies do this is they somehow create a mathematical representation of each user. Okay, so let's say that there are 5 genres of movies, right? Like romantic, comedy, action, thriller, horror, for example. And let's say that for each user, I write down the number of movies that each user has watched in each genre. And based on this, I get a representation of a vector representation of a user. Now, what I do is I have millions of users who are signed in on Netflix. I'll do a simple cosine similarity between, the user in consideration and all other users in parallel. So it happens really quickly. So what I'll do is using this, I'll perform clustering and take the users who are very similar to one another and see what kind of movies this group of users has watched. And based on that, I'll recommend the movies to this user. So that's a very simple, straightforward way of how collaborative filtering works in the user-user scenario. Now, let's look at the item-item scenario. This is a really interesting one. So what happens is, in this case, based on the products that you have been interested in, or the products that all are similar together, they are sort of grouped and recommended together. Now, a couple of years ago, Walmart conducted a study based on a very strange finding. So back when data mining was a very big thing, maybe in the early 2000s when it was all the rage, and all companies started to digitize their transactions and digitize their inventory and so on, Walmart suddenly found that a lot of male customers, a lot of men in US, ended up buying beer whenever they purchased diapers. Now, this was very strange. What's the correlation between beer and diapers? So when they performed a survey, they found that a lot of people who purchase diapers are mostly, new parents. Now these people end up staying up late at night because probably their child, does not go to sleep, or they're just tired, or they're just not, sleepy maybe. So now in those cases, since the US is a major market for consumption of aerated drinks and sugary drinks, they end up consuming beer because it's cheap. So what Walmart did was it capitalized on the situation and placed beer bottles close to diaper bags. Because of this, the sales of beer bottles and diaper bags just shot up, and it made a lot of profits. They wrote a paper on this and they called it the power of association. And a new slew of algorithms came out of this called association rule mining algorithms, which started finding these patterns where, okay, if this person buys item X, then it's highly likely that this person also buys item Y. So when you don't have too much information about a particular user, but you have a lot of information about the different buying patterns of various other users, you can use this sort of item based collaborative filtering. So that was about collaborative filtering. Let's move on to the next one, which is content-based filtering. So in the previous situation, right, collaborative filtering was used in cases where you don't have too much information about the individual user or the individual item in itself. You don't have a way to standalone describe a user or standalone describe an item apart from maybe describing things similar to a user or similar to an item. But with the advent of a lot of data management techniques and inventory management, people are now able to store a lot of information about users and about products. So you're able to describe a user based on location, where the user is located, maybe the age of the user, the occupation, the gender, some basic signals. And based on this information and the user's activity, companies are also able to derive their interests. For example, Google was able to derive that I bought a Kindle, so maybe I am a reader and maybe I should be suggested some books. And you're also able to say, okay, Nimisha is interested in books right now, but she has consistently been searching about plants, for example. So that's her long-term interest. Plants are her long-term interest, but recently of late, she's been interested in books. So maybe we should occasionally suggest books, but continue to suggest plants. They were also able to find out at what stage a user is at. So, the users are usually in different stages of shopping. They're probably in a stage where I'm not really going to purchase something today, I'm just researching. So the more options you show me, the better experience I have and the more I click on. So that's considered as successful for the company. Or if you're able to predict that I am at a stage where I'm definitely going to buy something, then it's great if you just show me the cheapest option, or if you show me exactly what I'm looking for. Also, there are certain signals which you can't really explain, but can be derived about a user. For example, let's say I'm on Myntra.com and I keep looking for animal print clothes, or I keep looking for clothes of zigzag patterns or something like that. Now, that's not something which is quantifiable, right? Like saying Nimisha is interested in zigzag patterns is not something that you can quantify, but it is an abstract interest that you can understand. And this is where deep learning comes into play, and I'll explain that in future slides. But there are certain unexplainable interests which can be captured about the user. So all of these things, once they're captured about the user, you have a lot of information with you, and you can make an informed decision as to what the user will click on next. And these are kind of content-based recommender systems, which the underlying algorithm can be anything. It could be the same as collaborative filtering, where you're kind of representing the user as a vector, and you're calculating similarities between different vectors. but it's just that you're using a lot of information about that individual person as opposed to in the previous case where you didn't really have it. So once companies realized that they could do both collaborative filtering with content-based recommender systems, they realized, okay, why don't we just combine the two methods, right? We can take several models and we can do a weighted average of those models. Maybe in the mornings, I can use this. Maybe in the afternoons, I can use another model. In the evenings, I can combine both the two models because people come back from work and they end up, sitting and going through a lot of internet, maybe Netflix. We can show a different set of models. So those are basically hybrid recommender systems. You have a combination of various models and various algorithms are at play. And actually, one of the examples that we saw was in Bing Shopping itself. During when COVID became, a huge topic of concern initially in March, there was a surge in N95 masks, and we wanted to suggest N95 to a lot of people, but we couldn't automate that with just collaborative filtering because not enough users had actually purchased N95 masks, so we couldn't rely on other users to give us information. So what we did was we combined collaborative filtering with a popularity-based model and rolled that out, and that increased the sales of N95 masks, and we had more clicks and impressions on our products. So finally, we come to deep learning and recommender systems. Most companies have now moved on to deep learning and recommender systems. Well, firstly, because it's the availability of code, the availability of compute power, the availability of memory, all of those things have made deep learning ubiquitous. And of course, saying that you are working on a state-of-the-art method is a huge bragging quotient to a lot of companies, which patent out their techniques, they write papers. So yeah, it's very popular these days in recommender systems. So before we actually move on to the ways in which deep learning can be used, let me give you like a 1-minute briefing as to what deep learning is for those of you who aren't familiar. So as we all know, artificial intelligence is something which can be used to make a non-living thing smarter, right? You want to teach it rules, you want to teach it, you want it to acquire knowledge, you want it to learn some ways of life, for example. That's called as artificial intelligence. Now, within artificial intelligence, one of the techniques to make something intelligent is to use techniques of machine learning, okay? So within machine learning, one of the ways to make the machine learn is deep learning. So that's probably the quickest way I can describe deep learning. So why is it called deep learning? Because we learn certain abstractions, which are considered deep representations because there are multiple abstractions learned for one single entity. So for example, if you have, let's say, a person whom you need to represent as a mathematical vector, how would you do that, right? For example, if I had to be represented as a mathematical vector, then you can't really, do it in a very easy way. So what you need to do is give this particular model or a system all of my features, all of my behavior, my activity, everything, and make the model keep learning about me over and over again and keep rewarding it and penalizing it based on what it predicts about me. So in that situation, a very abstract representation of me is learned by this model, and maybe it could be a matrix, it could be a one-dimensional vector, it could be anything that I want the model to learn. So this is a very deep representation, which is how the name deep learning comes. So I thought it would be interesting to talk about some case studies where deep learning would be used in recommender systems as opposed to just giving you theory about it. So this is one example that we tried out in Bing, and it's a very popular method which is used by a lot of companies and for experimental purposes as well. So one of the features that we had to roll out was related to items you have viewed. So for example, I'm looking for, say, running shoes, right? And the repository of, let's say the company has billions of shoes, right? You don't have somebody who can sit and pick the exact similar item which is related to the item that I have been looking for. So how do I do this? I need to represent each of these shoes in that abstract, deep way that I described for the previous slide, right? So I need to create a deep representation for each of these shoes. And then among all of those deep representations, I need to do a similarity search and get the ones which are very similar to what I have. How do I create this deep representation, right? So this was modeled as a classic natural language processing or NLP based prediction task, where each of the shoes actually they have these kind of names, they have descriptions and so on, right? So we used all of those descriptions and titles as text-based features. And I'm not going to go into the details of what this model means. I'm happy to answer questions towards the end of the talk or even after that, if you have any questions related to this. But there's a model called as BERT, which is used for state-of-the-art natural language processing tasks. So what we did was we fed a lot of text-based information to these BERT models, and it was able to learn a deep representation for each word. And using those words, we constructed sentences which represent the titles of each of the shoes. And based on that, we were able to get each of these to be represented as, a vector. And after that, it was easy, right? After that, we just do a simple cosine similarity and pick the ones that are related to one another. And that came out to be like a really good recommendation feature. And the number of clicks that we had on that carousel was really high and so on. This is just an example of how the model I designed worked, where I would, how I tested how it worked. So we had a repository of 1 billion products or even more, I think. And if I typed out something like Dell laptop Inspiron, I expected to see a lot of Dell Inspiron based products come up, right? Because that's what's related to this. Or if I looked for something as, terse as kitchen cabinets, and I don't really say anything beyond that, the model was still able to pick up products which are related to kitchen cabinets. And this is the kind of intelligence we usually would like to see in a recommendation system. So that was case study 1. Case study 2 is something which is, everyone would have done this in their life. Everyone has Googled something, right? So let's say you Google about, I want to watch movies about high school, okay? So how exactly does Google power this carousel here? How is it able to get these things? Nobody in the entire world ever will sit and tag movies saying, okay, this is about high school. Like it's just impossible to do that. So how is Google able to do this? So Google also does something similar to what I mentioned in the previous case study, where it takes the titles and scripts of each of these movies and it creates abstract representations of them, right? And it also creates an abstract representation of the term high school. And after these representations are created using various natural language processing tasks, Google is able to pull up the vectors which are close in space, and it just so happens that it's able to do that very beautifully because they have a lot of training data and they have state-of-the-art machines, and they have all the time in the world as well to get these kind of results. So they end up giving a really good experience for users every time you Google something, right? So I won't get into the details of each and every technique which is present in deep learning for recommender systems, but some of the ones that I want to highlight are, you must have heard of things like multi-layer perceptron or a feed-forward neural network, which is one of like the vanilla neural network, which you pass through your input, you get any output you want. It's a classic supervised learning method in which you're able to understand deep representations for anything and everything, right? Another way is a convolution neural network, which is also a feed-forward neural network, but it's mostly for multimedia-based inputs. So how do you pass things like images and videos and represent them into, how do you say that something like this looks like a flower, right? So what you do is you make this into a matrix of vectors, and you pass it through a convolutional neural network and make that network learn based on visual cues and penalize it and reward it accordingly. Similarly, there is something called as an RNN, which is a recurrent neural network. So this is really interesting, and highly used in almost every possible recommendation system today, because recurrent neural networks have these features called as gates. What they do is they're able to remember what needs to be remembered, and they forget things which are not really important. So this helps in understanding the user's long-term and short-term interests for a recommender system. For example, if I keep buying things on Amazon, it keeps a record of the order in which I've kept buying things. So, if this particular sequence is passed through a recurrent neural network, and the network is made to learn what I'm going to buy next, or what I'm going to buy 3 steps from now, it's able to learn that really well. And Amazon can make a very good high confidence prediction as to what I'm going to buy today versus what I'm going to buy maybe 2 days from now. And it can stock its warehouse also accordingly. And as usual, a lot of companies realize that there are multiple techniques for deep learning. Why don't we combine all of them? And one such beautiful combination is in this company called as Pinterest. If you haven't ever checked it out, you should. It's one of the best recommendation systems out there. What they do is they allow you to search for things, and they allow you to pin them. So you can search for something like, a chocolate strawberry shake, and they're able to recommend things like smoothies, strawberries, and other food related things to you just based on visual cues. They're able to extract this text and suggest it to you. So what they do is they end up using, convolutional networks to get all these visual cues, and they use things like RNNs for sequence-based learning as well. So they combine everything, and it's just a nice model biryani right there. So now we come to recommendation systems in production, right? So how do we put all this into the wild? How does it work? So let's look at a simple scenario. I am a user. My interests are already known to someone like let's say YouTube. They know that I'm interested in, for example, phones and gadgets. But let's say I enter YouTube and I end up looking a lot, searching a lot about shoes and running, right? So right now they need to update the fact that I also like shoes and running in their database, right? So how do they do that? And how do they serve recommendations based on shoes and running to me later? It's divided into 2 parts. One is the offline part and one is the online part. So the user enters the interface, something like Netflix or YouTube. And what happens is this interface is basically powered by user features, which is basically a database of me, my login details, where I live, my age, anything that can be extracted about me, and item embeddings. Now, these are whenever I say embeddings, I mean to say the deep representations of the products, which have been computed using these deep learning techniques, right, which I described in several slides. So those are also stored as databases in databases. So, okay, the user is here. How do I populate my interface to show this person the right recommendations, right? So how do I show him or her the right experience? So what happens is the recommendation system model, which I have trained, right, in the past, I should have hosted that somewhere. Okay, so this model knows, okay, for this user, I have all of these features. So if this kind of a person comes to me, I need to show these kind of items to this person. So this model, what it does is it performs inference. Inference is where you make predictions based on the pre-trained model weights for a given input. And based on those, the predictions, another ranking step happens. And based on that, the recommendations are given. Now, if we go back to the example that I gave where you were picking a movie, what you essentially did was you came to the interface, which was your friends, right? Your friends kind of thought about you and they thought, okay, Nimisha might like comedy movies. Let me suggest a comedy movie to her. And it suggested a bunch of things. And based on that, you are saying, okay, they gave me a bunch of comedy movies. Do I like it? Do I not like it? And that's based on that, I either watch it or don't watch it, right? So that's what exactly happens even online when we go to any website. So that was all about how embeddings are served online, but actually the important stage is in creating that model, right? Which is sort of the entire oracle which drives this whole process. So for that, you need to perform data collection. You need to find a log of like all of the user activity, understand everything you possibly can about the user. Of course, you need to be privacy compliant here. You can't, you need to anonymize your data and keep it. That's a huge hugely invested part of recommendation systems. Second is you need to define your problem statement, right? Are you recommending a product based on the user? Are you recommending a product based on a product? Are you recommending something for the user to search right now? Like what is it exactly? What kind of a feature are you designing? And based on that, you create your features, right? In order to create the model to learn whatever you want the model to learn. So right now you have collected your data, you've defined your problem statement, you've cleaned your data and created features. Now all that's left is to train your model, right? Now, training is a very like time-consuming process if you don't have the right resources. So you have to make the training process as quick as possible and as memory efficient as possible. So you have to make use of things like TensorFlow, PyTorch, and make them multi-GPU compliant, make them shard your data and do data parallelism. All of these things are really important when you are looking at production because you're serving millions of users, right? So you need these things to happen on, forget daily basis, they need to happen on an hourly, minute basis. And the second thing is you have to store all of these computed embeddings in consistent databases. You can't just store it at one place. For a company like, say, Google, there are millions of databases all spread across the entire world where there are copies of the same embeddings in multiple places. So those are all data management techniques that you need to handle, and preferably need to invest in key value storage because you have frequent updation, right? So once you have your model ready, what you need to do is before you release it into production, you have to do something called as A/B testing. You need to release it slowly to just a few people and see, okay, how are these people exactly liking it? Are they liking it? Are they not liking it? So that's called as A/B testing, where you have a control and a treatment group, and you only release the product to be seen or the feature to be seen to one of those groups, and you measure, you of course decide your metrics beforehand. Maybe there could be clicks, maybe there could be conversions on ads, so many things. So define your metrics, perform A/B testing, see whether you're getting more clicks based on whatever recommendations you have served. And if it is, then yeah, you can put your model into production, right? So I cannot not talk about this when I'm talking about recommendation systems, where one of the most important thing, as I said, was you have to ensure that there's no data leakage. The people who are training, testing, like employees, shouldn't have access to, who the user is and what their information is. So it has to be anonymized. And if that user is, if they leave the recommendations, like if they leave the particular system and go out, then their data needs to be deleted, right? You have to make sure that your model is hosted online, and you have to make it small enough and compact enough so that the inference happens in time. And so the inference happens in time. You also have to make sure that your products, which are billions and billions of items, which keep changing every day, need to be updated everywhere across, the world if you have different data centers. So you need to have good support for that. So as I mentioned in the previous slide, several of what I said are actually challenges, right? You have millions of users, you have billions of products. Even for just 1 million users, if each of them have a 1 KB representation as an embedding, it's 1 GB, and for 1 billion products, it becomes 1 TB, so it's expensive. So you only need to store maybe the most actively engaged people or the most popular products or things like that without introducing bias. You have to ensure that, if I'm a user, I come and use your website, and I go back and I come back the next day, the experience has to be updated. So you have to make sure that, or if I come back later on during the same day, your experience has to be updated by then. Many companies do that already. So, the time taken to capture the new activity, perform model inference, and then pick the newer embeddings to populate in the final user experience, all of that needs to be minimized. So you have to sort of take care about, okay, what do I use? Do I use Elasticsearch? Do I use Spark? Do I use Hadoop? What kind of a big data ecosystem do I use? All of those things. And the most important thing is you need to retrain your model every so often, because it's possible that people's buying patterns change. It's called as concept drift and model drift, where people might be purchasing in a certain way and it completely changes. We saw that happen with COVID, right? A lot of people have resorted to online purchase of every possible thing right now. So yeah, so these are some of the challenges for recommendation systems, but if they're all executed well, it can certainly boost like the business by a huge amount, because you're giving the user what they want sometimes when they don't even know they need it. So I think I've sort of reached the conclusion part of this presentation. I'd just like to say a few words about what we could expect the future of recommendation systems to be. We've already reached a stage where deep learning algorithms are powering intelligent recommendations or suggestions for users. But going ahead, the entire recommendation ecosystem itself can become something like a blueprint. Actually, Amazon has already done that with it's something called as Personalize. They're selling an entire recommendation system architecture itself, and there are thousands of people who are already incorporating this into their companies. Like I think Intuit has already incorporated this into their company, and so on. Of course, the next order of business would be reinforcement learning, where without even training a model, you can perform some sort of suggestion. You can perform some sort of recommendation service. Actually, Google is already doing that a little bit with their ads, and of course, there are endless opportunities. It's an extremely exciting space. It's a space where you need to be ethical and responsible. And as I said, if executed well, it can bring a lot of boost the company's profits a lot. So with that, I think my presentation has come to an end. Thank you so much for still being around. I hope it was useful, and please, if there are any questions, I'll be happy to answer.
Thank you, Nimisha. That was a wonderful session. Any questions from the audience? Yes, we have a chat message here. We have Shri PG Bhatt sir here. He's saying, thank you, Nimisha, for the excellent talk, summarizing the recommendation system. I would love to work with you on some social causes.
Oh, thank you. Definitely, sir. I'm not sure how to share my mail ID, but if the organizers have some way of doing that, I'll be happy to do that.
Absolutely, Nimisha. Okay, another participant is thanking you for the wonderful session. That's Vibha. Thank you, Vibha.
Oh, thank you, Vibha.
Nimisha, I have a question here. During the recent lockdown period, when humongous data was generated, the transactions that were carried out every single second were obviously numerous. So what challenges, I obviously remember the challenges slide that you just showed during the talk. How did that time period impact, or what challenges it further added to the list that you already put in the recommender system?
Great question. It's something that we are still trying to fix, actually. So the amount of requests that suddenly increased online was tremendous. And there was simply no other way than to purchase more machines, because we sort of measure this as QPS, or queries per second, right? So there was simply no other choice than to increase the investment in compute power, or in memory for that matter, because as we realized, there was no change in, the intelligence behind it. There was only a change in serving the recommendations. So we did notice that the website started becoming slightly slower because several requests had to be served. But apart from just handling it from a purely data management perspective, we were not seeing that much of a change in the recommendation system. I hope that answers the question.
Yes, absolutely. Thank you so much, Nisha. We have a couple of more messages where let me quickly read them for you. Dr. Radha Gupta says that it was indeed an exceptionally well put presentation, and also she likes the style of your presentation. Again, Mr. Ravi Kumar from PESSC says that it was an excellent presentation. Dr. Suma says, can we use Fourier transformation for the deep learning product recommendation?
Yeah, definitely. Actually, if Fourier transform is the only issue is that the Fourier transform is very computationally expensive. So it might be difficult to do this online. But it's not something which could be, I don't think it could be differentiated to be put into the nonlinear transformation part of deep learning. But I believe there is a slew of research coming out from Google Brain, which says that, they're trying to solve problems in imaging, medical imaging, and they have come out with Fourier transforms and wavelet transforms and things like that. I don't have too much knowledge about it, but definitely they have written about it in their most recent paper. Thank you so much for your kind words.
Thank you, Nimisha. Dr. Amuta from Department of CSE also says here that it was an excellent presentation. Thank you, Nimisha, from on behalf of all the participants here. It was really a well-put presentation and easy to understand content, and that's why we're all able to relate it to our day-to-day activities and the topic that you just presented. Thank you so much, Nimisha, for your time. And
thank you so much. I hope it was useful. Thank you so much for the opportunity.
Absolutely. Thank you so much.
Thank you. Bye.
We now move on to the first plenary session of the day. We have with us Dr. Mathirajan M., Professor, Department of Management Studies, IISc Bangalore. He will be talking on a machine learning algorithm for scheduling a burn-in oven problem. To introduce the speaker, we have with us Dr. Amuta S., Professor from Department of Computer Science and Engineering, DSCE. Over to you, ma'am.
Yes, ma'am. So good morning once again. Feel happy to give a brief introduction about Dr. M. Mathirajan. Dr. Mathirajan is working at the Department of Management Studies, Indian Institute of Science, Bangalore, since 1986. Currently, he is the Chief Research Scientist at IISc. He received MS Engineering degree by Research in Applied Operations Research Area and PhD degree in Operations Management Area from Indian Institute of Science, Bangalore. In addition, he holds MSc degree in Mathematics and postgraduate diploma in Operations Research of Anna University, Chennai. Dr. Mathirajan was a postdoctoral fellow at Singapore MIT Alliance, SMA of Nanyang Technological University, Singapore. He was also a visiting consultant at Sultan Qaboos University, SQU, Oman. Dr. Mathirajan was selected as Young Indian Representative of Operational Research Society of India, ORSI. Dr. M. Mathirajan is the Associate Editor of OpSearch, the flagship journal of Operational Research Society of India, published by Springer. The ORSI awarded the Fellowship of ORSI to Dr. M. Mathirajan based on the assessment by the Standing Committee on the merit of the contributions towards the promotion and development of operational research carried out by him and approved by the National Central Council of ORSI. He was elected as one of the National Central Council member for 2 years. He is a Vice President of Operational Research Society of India, Bangalore chapter. He is also the Vice President of Analytics Society of India. Dr. Mathirajan's PhD thesis was adjudged as Best Thesis for M.N. Kobalan Award of 2002 Annual Convention of ORSI. He has published over 195 research articles. He is the co-author of 2 books published by PHI and co-author of 4 edited volumes published by CRC Press USA. So far, 9 dissertations were awarded PhD degree under his guidance in IISc Bangalore. Currently, he has been guiding 8 doctoral research students at IISc, and he has examined about 60 PhD theses from various higher learning institutes. Thank you, Dr. Mathirajan. We request you to start with the presentation. Thank you.
Thank you, ma'am. Audience, kindly give us a moment to, I think sir will be joining shortly. Kindly give us a moment. Thank you.
In the meeting, madam. Okay.
Good morning, Dr. Mathirajan.
Good morning, madam.
Thank you for accepting our request to give the plenary session here for our audience. Thank you so much. You can now share the presentation.
I'll just join in 2 minutes. I'll just join in 2 minutes.
Sure, sir. Sure, sir. No problem.
Hello, can I share it?
Yes, sir, please.
You cannot start screen share with other participant is sharing. Something is message is coming.
It's now off. You can share it, sir.
Okay. Just opening my PPT. Okay.
Sure, sir, no problem.
Just check and tell me whether it's visible by you or not. Okay.
Yes, sir.
Hope you will be seeing that.
Yes, sir, we are able to see it, sir.
So now you tell me.
Yeah. So we now have Dr. M. Mathirajan from the Department of Management Studies, Indian Institute of Science, Bangalore, to give us a talk on a hybrid neural network approach for scheduling a burn-in oven of semiconductor manufacturing. So over to you, sir.
Okay, very good morning to all of you. Especially, I would like to thank Dr. Radha Gupta for giving this opportunity to share my experience, particularly research experience in scheduling a burn-in oven. This particular paper is not done by me. Of course, we extended this idea, same burn-in oven scheduling, we extended with the same paper that has been submitted for the journal. So I'm not presenting that part. Whereas the base paper, what we have used it for extending that scheduling a burn-in oven, I'm going to present it to you to get some knowledge about how that particularly artificial neural network is used in scheduling a burn-in oven. Generally, we say that when artificial neural network is used for predictive modeling, recently people started to use for prescriptive modeling also. This particular study is related to prescriptive purpose. Okay. Otherwise, generally it's used for predicting anything in the for the future activities. So I'll just give some first few. I think my total time is 45 minutes if I'm right. So first 30 minutes I'll give you the importance about the problem perspective, and then I'll give the architect of HNN. Quickly go through some kind of slides which has been implemented as a part of this burn-in oven scheduling. So what is scheduling? Because basically scheduling is nothing but a decision-making process of allocating any limited resources. When you're having a limited resource, only the question comes, particularly related to your particular activities over time, and its goal is to optimize either single objectives or multiple objectives. Essentially, scheduling is nothing but a job sequence. There will be a set of jobs waiting in front of the machine. You need to find out what is the sequence in which I can schedule and what time I'm supposed to schedule. Sequence and time both together constitute a schedule. The scheduling actually started with the manufacturing. Afterwards, people have introduced scheduling for computer-related activities, human-related activities. But my presentation is manufacturing-related activities, particularly semiconductor. But quickly, I can give you how this production scheduling or manufacturing scheduling can be grouped into that or classified into that. Static scheduling, dynamic scheduling, one aspect, or deterministic scheduling or stochastic, another way of classifying. The scheduling is related to single product and multiple product is another way of classifying. Scheduling only single processor or multiple processor. Whatever this particular paper is related to static scheduling, considering deterministic situations, considering multiple products, and considering only single processor. Our extension is related to dynamic. That portion we are not discussing. Whereas this particular paper, whatever I'm going to present, this paper already published by X or Y. So this paper is related to static scheduling of burn-in oven using HNN. In our extension, we use dynamic case, and some more additional feature also we added. So a little more details on scheduling. While traditional scheduling are primarily concerned with sequencing, if you remember all people, the modern manufacturing environments, they provided additional features because of various new findings or innovation has started with that. Instead of doing their jobs in a different perspectives, they can do it in a batches, which leads to scheduling problems with batching. There are two types of batching normally you can come across in the scheduling language. One is called serial batching, another is called parallel batching. The serial batching is normally happened for the machine which is nothing but processing one job at a time. It's called discrete processor. Whereas parallel batching is related to machine itself process simultaneously more than one jobs. Okay. So serial batching jobs may be batched if they share. Why the people are forming a batch for a machine which is processing one at a time? to reduce the setup times, because every time there is a set of jobs require a specific setting times, they group all the jobs which are having a similar type of setting times. They will group that job, group the set of jobs that called as a batch. That time also is called as a serial batching, whereas the processing happens one job at a time. Whereas parallel batching, simultaneously we can process many jobs at a time. It's like equivalent to a very local level example. If you want to give it, serial batching is nothing but some kind of dosa making at home, and then parallel batching is some kind of idli making at home. Just as an example, this is a very colloquial example, but this is analogically it's true also. Only thing in the parallel batching, whatever the set of jobs you are putting inside that particular machine is called as a batch processing machine or batch processor. The starting time, ending time supposed to be the same. Okay, and in between you cannot take any set of a few jobs and then replace set of another jobs. It's not possible. That means interruption is not possible. So parallel batching, this particular study is related to parallel batching. Why people are giving too much importance on parallel batching? Though to considering only one machine in the entire shop floor. In the shop floor, you may be having few, maybe 10 or hundreds of processing machines will be there. When you are having hundreds of machine processing, why we are giving only one machine, giving more importance for scheduling? Generally, these parallel batching processing machines are kind of batch processing machine or batch processor, simply we call it. It becomes a bottleneck in every industries that has been identified over the period. These are the possible various industry you can come across, we have come across so far, though we started somewhere in 2000 and odd. Now the number of industry keeps on introducing the new type of processing facilities like batch processing machines. And not only the manufacturing industry, even the service industry, people started to look into this type of batch processing applications. For example, hospital industry, one of the service industry, there is a process called sterilization of any reusable medical devices. Before using that reusable medical devices, they will put it in a sterilization process for taking to any operation status. So this type of applications are plenty. The main reasons for this plenty of application is every batch processing machine, whatever we have come across in various studies, they claim that one this becomes a bottleneck machines or bottleneck processor. Why it is bottleneck? I just give you some reasons. Important reason is the processing time when you compare with any other machines. I assume that when even there is a manufacturing organization, if you are having 20 or 30 processing machines are there, if there is a batch processing machines, that computation, that processing time is comparing with any other processing time of the remaining machines very, very high. When it is very high, this is the one processing machine decides the production rate of the entire shop floor, number one. And also because of this taking longer time, and also it's a batch processing machines, that means right jobs you are supposed to place it inside this particular batch processing machines. The main reason is processing time at batch process is often very long. When I say often very long, it's not a small marginal difference. For example, every operation takes about in terms of minutes, whereas this batch processing machine takes in terms of hours. Sometimes it takes in terms of days also. Since it becomes a bottleneck, suddenly as a human thinking comes, can I get some multiple machine and put it along with the parallel manner? So instead of having only one batch processing machine, I can go for another batch processing machine so that the set of jobs waiting in front of the batch processing machine can be avoided. But the cost of the equipment is very high. It's not really easy for you to buy left and right of this type of equipment. Since the cost of the equipment is very high and this production rate is dictated by batch processing machines, everywhere people say that when considering only this single machine and scheduling appropriately or efficiently, effectively, that takes care of the throughput. Throughput is the main one of the performance measures people always expect from the perspective of organization perspectives, either throughput or utilization of the entire resources. Or if you talk about the customer perspective, then due date may be the one of things. But this particular study is related to organization perspectives. We'll see that what is the specific objective they consider in this paper. Okay, this is true for every batch processing machines. You need to trade off between the efficiency versus effective utilization of this particular batch processing machines. So that's why it's becoming a bottleneck and important in scheduling literature, and people are continuously concentrating. Even though it's only single machine, how do we go and schedule it? If I properly schedule these single machines, there is a possibility of getting the production rate will be improved and then throughput also will be achieved. So this particular study is related to semiconductor manufacturing. Semiconductor manufacturing, generally, there are 4 phases in semiconductor manufacturing. First phase is called wafer fabrication. Second is wafer probing. Third is assembly. Fourth is a final testing. Each and every phases, you can come across some kind of batch processing machines. Every stage, the batch processing machine accounts for longer processing time within that each stage. In wafer fabrications, batch processing time is accounted for 70% of the entire process related to wafer fabrications. Coming to our final testing there, our interested topic is related to burn-in oven. The burn-in oven batch processing time is roughly about 50 to 60% of the entire final testing operations in the final testing area. So this particular study is related to burn-in oven. I'll spend some couple of minutes or maybe a few minutes. What is burn-in oven? How this processing is happening? Okay. What is the why this burn-in oven? Also the same reason I already have highlighted. It is bottleneck because it is taking very long processing time compared with any other operations in the final testing area of the semiconductor manufacturing. And the cost of the equipment is very high, so you cannot take buy many burn-in oven and then to avoid the delay of jobs are getting processed in burn-in oven. In turn, you will get some kind of throughput as well as other performance measures. So this is what we need to see that one of the reason is burn-in oven scheduling is also computationally taking longer time, and then it becomes a bottleneck. What is the purpose of burn-in oven? So it is nothing but to test the IC chips. What is the meaning of testing the IC chips? Because the area itself is called final testing area. There is a last stage in the semiconductor manufacturing is final testing. Different type of testing they will do it. This specifically, this burn-in operation testing is for what purpose? I can just give you that one. Since the chips, right from the wafer fabrication to the final testing, it goes through various processes. It may be running to something like 1,000 level of processing. Since it's going to the various process, there is a possibility that device will become, device in the sense is ICs, integrated circuit chips, or we can call it simply ICs. Okay, it become a fragile and may fail after some time. I need to find it out whether it is tardy or it going to become an infant mortality even before taking these particular chips to a particular product like mobile or computer or any other device. So our objective is to find out whether any defect of the chip is there. It is better to find out in the manufacturing organization itself or in the testing area itself, so that we can avoid that device, that IC goes for a final product as a component. So essentially, the process to identify this scrap, identify this fragile IC chips and scrap this fragile IC is called as a burn-in operation, in other words. So this IC is known as burn-in. That is, we are calling this as just as a burn-in operations. So that means the devices ICs are, they put it in the burn-in oven, this kind of oven. It's like a Almera kind of things. The oven looks like Almera. There will be multiple trays will be there. All the ICs are placed in the tray, and then trays are placed it inside the Almera. All the trays are removable type in the Almera kind of facilities. Okay, so all the chips are placed in the tray, and then they put it for electrically and thermally to force the failure of weak or fragile device. They will take some highest temperature like 150 degree C, and then they keep this entire trays inside this burn-in oven for a specific durations. Say maybe about few hours to 48 hours. It's again, I'm sorry, using the same colloquial example, idli. If you want to put all the idli inside, you need to keep some temperature and then keep for sufficient time to make sure that an idli is ready for you. Similarly here also, if you open it in between, not giving appropriate time, the idli will not be possible to eat. It is in a poor condition to eat, or it will stomach get upset kind of things. Similarly, if you open in between the specific duration after few hours or 48 hours, if it is extra time is there, okay. But minimum times you have to keep it inside. That's also important here. So this is what main purpose is happening for the purpose of burn-in oven. Okay. Particularly some of the chips goes into the aircraft kind of things. It takes 240 hours time in burn-in oven. It's not like a few hours. It's supposed to be tested about roughly 240 hours. A particular chip goes into the aircraft. So how this process is happening in burn-in oven? Just give quickly some idea about it. Generally, burn-in oven is one of the operation in the entire final testing area. It comes in between the final testing area. I assume that in the final testing area, there are about n number of operations are there. It may be the kth operation where ki is less than n. Okay, it may be the kth operation. It becomes a burn-in oven operations. So all the IC chips comes before the kth operations comes in terms of a lot. So each IC chips required a specific burn-in times. For example, chips which goes into the mobile may require 2 hours in burn-in oven as a burn-in purpose. Okay, the chip which goes into the computer, it may require 4 hours or 8 hours in the burn-in operations. Like that, each and every chips has pre-specified burn-in minimum burn-in time. Who will be giving this one? The customer will ask the semiconductor manufacturing people, please deliver our all the IC chips which they are going to use it for assembling their final products. Say that, and please put it in the final testing area, particularly in burn-in oven, this many hours. That will be normally specified by the customer. Okay, and also it depends upon the type and or the customer requirements. It varies. And the set of ICs ordered by each and every customer, it's called as a lot size. So I would have ordered some 1,000 chips related to my final products. Okay, this 1,000 chips called as a lot or job. All this, each and every lot size is called as a job. Just at that point, it is more than enough. Important to note that one, all these 1,000 chips are going to be placed in a tray. It cannot be put each and every IC simply onto the burn-in oven. It's supposed to be organized in the tray. Each tray is a product specific. So then we need to put it in the tray, and then the tray is only supposed to be placed inside the burn-in oven. That means each lot takes some specific number of trays. A particular lot may require 4 trays, another particular lot may require 5 trays, another particular lot may require 6 trays. That means each and every job order requires some kind of job size. In other words, number of trays required. The number of trays required is also important input for taking a scheduling decisions. That means each job has a different lot size. That means it requires a different number of boards to place all the chips, and then in turn placing inside the burn-in oven. Then how do you measure the burn-in oven capacity? The number of trays is possible to place inside the burn-in oven capacity is called burn-in oven capacity. So the number of trays required for each and every lot size is assumed to be less than or equal to the number of trays possible to place it inside the burn-in oven, because the capacity is always higher than the individual jobs require the number of trays. That is always we need to make sure the things, because splitting of job is not allowed. One particular time I'm putting in the burn-in oven, remaining set of jobs I'm putting in the second burn-in oven, it's not allowed. So since the splitting is not allowed, we always assume that one job size is always less than or equal to batch capacity. In other words, number of boards required to place it inside the burn-in oven. Okay, then assume that I just mentioned that one, each job requires a specific burn-in oven times. There are 2 ways we can place all the chips inside the burn-in oven through the board. The jobs which are requiring similar number of processing times, all are requiring 2 hours times, I can put it inside. I can open that burn-in oven after 2 hours, I can take out all the chips and then pass it on to the customers. Since it's a minimum burn-in oven time only it is there, even if you put extra, it does not affect your burn-in the chips. So sometimes people have researched and then said that one, even I can put it any set of jobs which requires different burn-in oven time as a batch. That means the jobs which are requiring 2 hours, job requiring 4 hours, jobs requiring 6 hours, jobs requiring 8 hours. These are the 3 jobs, assume that one. All the 3 jobs I can put it inside the burn-in oven. But only thing, the burn-in oven processing time is nothing but the maximum of this burn-in oven time, because as per the conditions, the starting time, ending time supposed to be the same. When you place the chips inside the burn-in oven, you are supposed to take it in the end after the entire processing is over. Where is the chips requires 8 hours. That means the highest duration is 8 hours, so we can open it after 8 hours only. That means every burn-in oven, particularly batch capacity, batch processing time is decided upon what type of jobs you are placing inside and its associated burn-in oven time. If different burn-in oven times are there, related to a set of jobs you placed inside the burn-in oven, always your processing time is nothing but maximum of the processing time, which is related to a particular job. So this is also important to note that one as a scheduling method it is required. So just as an example, of course, assume that when there are 10 jobs are given, to highlight whatever I given conceptually, there are 10 jobs are given. Each job is having a different processing time. Assume everything is in terms of hours. Job 1 requires 10 hours, job 2 requires 11 hours, job 9 requires only 1 hour. So that in the end of 10 hours, 11 hours, 6 hours, 8 hours, the job is ready for transferring to the customer. Customer in turn, they can use it for assembling their final products. And job 1 requires only 2 trays. Job 2 requires 3 trays. Job 3 requires 4 trays. Okay, the lot size may be in terms of thousands of jobs, but number of trays which occupies all this lot, that will be the job size. Okay, and the batch capacity for our numerical example, we assume is at 10. That means 10 trays I can place it inside the almirah or inside the burn-in oven. Okay, so oven is nothing but almirah kind of things. Okay, in this case, the each and every job 1 to 10, they assume that when they given to you, how do I schedule these 10 jobs? In other words, all these 10 jobs are available at particular time. So equal importance, that means static case. In the reality, the job 1 would have come before job 2, a job would have come after job 7 or some kind of things. That means every job would have arrived in different points in time. If I'm taking care of this arrival time also into that while scheduling, that time I can call it as not a static scheduling. I can call it to some extent as a dynamic scheduling, including future arrival of job also I can consider. But these people have considered only static scheduling. Okay. Then what is the performance measures I can consider for scheduling? So these people have taken minimizing the total completion time. The objective is to make sure that what are the jobs waiting in front of this burn-in oven, they want to minimize the waiting time. In other words, work in process inventory cost, they want to reduce it. If they wait for a longer time, then inventory cost will be more. That means why it's called work in process inventory, already there are multiple processing has done, and in front of the kth operation it is waiting. So that means it is a semi-finished process, semi-finished manner. It's IC chips are ready for giving to the customer. That's why all this work in process inventory holding cost can be minimized as a proxy measure for minimizing the total completion time. We cannot directly minimize the work in process inventory through the scheduling. We need to have a proxy measure. One proxy measure is called minimizing the total completion time. Similarly, if you want to minimize the throughput, there is a proxy measure called Cmax, minimizing the completion time of the last job or last batch. Of course, in this case, they've taken a minimizing the total completion time. So problem specifically, these people wanted to schedule given n jobs which are having different processing time, which are having different job size. Okay, with the objective of minimizing total completion time. But they have only one burn-in oven. The problem has only one burn-in oven, but in the reality, they will have a multiple burn-in oven. If you are having multiple burn-in ovens, still one can do that one. But for this particular authors have done it with respect to only single burn-in oven, whereas our extension of the study taken care of a multiple burn-in oven. Instead of static, we have taken dynamic. Okay. So every problem has set of assumptions. This particular problem, they assume that when n jobs are given at all the n jobs are available at time t equal to 0. Okay. And all jobs are having data related to processing. In burn-in oven is deterministic unknown. Like a processing time is, there is no variation in the processing time, and size also doesn't vary. Whatever the data required for scheduling, it is deterministic and certainly known to us. Okay. And all the jobs are available at the beginning of the planning horizons, and the capacity of the machine is equal to C. That is, C is nothing but number of boards which we are placing inside the burn-in oven. That is also a fixed one. And once if you start the processing of burn-in oven, you are not allowed to interrupt. That means once you put set of jobs inside the burn-in oven, you have to wait for till the last jobs to get completed as a burn-in oven requirements. No split of lots of jobs during the formation of a batch. So the process name of batch, already we mentioned that one, longest process name of all the jobs in that batch. Just we have mentioned that when if you're having 3 or 4 jobs inside the burn-in oven, the processing time is decided by the job which has the longest processing time, because you cannot open in between and take out any jobs. The interruption is not allowed. So this is a kind of 3-field notation in the scheduling logic. I just skip that one. So this is the mathematical model straightforward. So our objective is to minimize total completion time. C is nothing but Cj is a completion time of the jth job. Each and every constraint you can easily go through the things. The first constraint is nothing but every job can be placed in only one batch. Okay, so every job cannot be placed in multiple batches. Once if I decide a particular job is going to batch 1, that means it is not available for batch 2, batch 3. That means it's a kind of assignment, partially assignment kind of constraints. Okay, once if I place a particular job in a particular batch, that the batch size is always supposed to be checked. There will be more than one jobs can be placed inside the batch 1. That means the size supposed to be less than or equal to the size of the batch. This is a batch capacity constraint. The first is a job assignment. Job can be assigned only one batch. The second is a so-called the number is 3. The third constraint is nothing but job size cannot exceed the capacity of the furnace or burn-in oven. The fourth constraint tells you your batch processing time of a particular batch always depends upon the job which has the longest processing time of a particular job. That means many jobs may be there in the batch, but the batch processing time is always greater than or equal to the job which has the highest or longest processing time. That's why PB greater than or equal to that one. Then the fifth constraint tells you what is the first batch completion time. It should be greater than or equal to first batch processing time of a batch 1. Greater than or equal to, in this case, equal. Why we are putting greater than or equal to? Sometime it maybe we have to add some kind of waiting times. Otherwise, C1 equal to P1, I can put it. Second batch onwards, what is the completion time of a batch? The previous batch completion time plus processing time of the current batch which you are going to do it. That's simple mathematically we can write it. This is batch wise we have written what is the completion time. Job which goes inside the batch, how do I know each and every job completion time also we need to calculate it, that in turn will calculate the total completion time. The completion time of every job is supposed to be greater than or equal to completion time of the batch which has that particular job J. If that particular job J is assigned to the particular batch B, that means xjp equal to 1, your completion time is exactly greater than or equal to completion time of a batch B which has that particular job. If the job is not placed in that particular batch B, then xjb equal to 0. Am I right? Then it will take some kind of SCB minus M is a very large number. How do you get the M is a very large number? I can assign some number logically equivalent to some kind of C max value. What is the last completion time of the last job? That is mathematically we can take it and assign the values of M. So then all other variables are greater than or equal to non-negativity condition, and our decision variable is a binary variable. So this model looks very simple, formulation wise, not very complicated. But coming to that implementation for a large scale problem, that time you know that this model may not be possible to use it for a large scale problem because of the computational intractability. Just I can demonstrate that one. There are 30 problem instances are taken. Okay, each problem has only number of jobs equal to 10. The 30 problem instances, each problem instance having only number of jobs equal to 10, but each problem we are giving a different processing time. Each 10 jobs will have a different processing time. Each 10 jobs will have a different job size. Just only that only varies, but number of jobs equal to 10. So just I wanted to study whether what is the computational time takes, whether it is for every, when the number of job size equal to 10, it's supposed to take, assume that when same number of, same amount of computational time, then it is a kind of predictable. The computational time is predictable. If I'm not able to predict the computational time, when the job size equal to one set of problem instance has a 10, another set of problem instance has a 10, another set of problem instance 10, but the size same, but the computational time is varying enormously. So that time it says that it is one kind of computational intractability issues. So every problem, 30 instances we have taken, n equal to 10 only job size. Just this side, right side, I can give you what is the minimum CPU time taken out of 30 instances. One instance taken only 2 seconds. One particular instance taken only 2 seconds as a minimum CPU time in a AT, that's a computer machine environment. I'm not given. Maximum CPU time it takes 4 hours, 21 minutes, 5 seconds. 2 minutes, sorry, 2 seconds versus 4 hours. And your standard deviation is about 1 hour, 4 minutes. That means you will not be able to definitely say one more 10 jobs I'm coming. What could be the computational time? You will not be able to predict because this is unpredictable manner it is there. That means non-deterministic. You cannot deterministically say what could be the computational time takes. Another 10 set of jobs, I can give it to you. Another one is also, of course, this non-polynomial. I cannot be able to get it because non-polynomial, if you want to get it, I have to give a different job sizes. When it having 5 job size, what is the computation? 6 jobs, 7 jobs, 8 jobs, 9 jobs, 10 jobs. Like that, and increase the job size, then I can put a computationally some graph. I can make it. The graph looks like a exponential in nature. That means this particular problem is a classical combinatorial optimization problem, or we call it a NP-hard problems. So since problem is NP-hard problem, NP is not for non-deterministic and non-polynomial problems. So since it's related to NP-hard problem, we need to go for alternative methods for really getting a solution for real life size problems. If it is only 10 jobs, you can get it. Even I can wait for 4 hours. But nobody will wait for 4 hours to get optimal solutions because here itself there is an evidence. That means they have to go for alternate procedure to get some kind of near optimal solution. Even if you are able to get it, it's more than enough. That's why just analogically we can say that when all our mathematics professor and computer science professors or faculties are participating in the transportation problem, instead of waiting for UV method to give the best solutions, sometimes people will compromise with the Burger's approximate method because most of the time Burger's approximate method gives near optimal solutions. Like that, we need to develop some methods similar to like a VAM, supposed to give some kind of near optimal solution even after applying the UV method. Whatever the solution I'm getting, almost I'm getting the near optimal. For even student point of view, sometimes even examination point of view, if you apply the VAM, the next iteration itself will become an optimal solution because VAM solution itself is an optimal solution. Like that, we need to develop some kind of good heuristic method so that we can make use of it as a kind of near optimal solution approach. So in this particular paper, they used or not used, they developed hybrid neural network approach to get near optimal solutions. Okay, What is this hybrid neural network? First, I'll conceptually tell you what these people have done it. There is a standard simple heuristic methods available in the literature. They already proved it's a very powerful heuristic in terms of greedy manner. I can get the solutions, greedy heuristic algorithms. Okay, so there is a simple greedy heuristic algorithm is there. That simple greedy heuristic algorithm taken and it is integrated with artificial neural network and then develop some new method. It's called ICAAICM2020. So that method they compared with before incorporating with the NANN, what will happen to the simple greedy heuristic algorithms. After incorporating this artificial neural network along with the greedy heuristic algorithm, what is the solutions? They proved in terms of comparing with the optimal solution on a small scale problem. On a large scale problem, they compared with the lower bound. They can find it as a lower bound. How do you get the lower bound in this type of problems? You all know that one. There is a mathematical model. It's a zero and integer linear programming model. I can relax that zero and integer linear programming model as a LP relaxations. Once if I get a LP relaxation, the LP relaxation solution is nothing but a lower bound for a mathematical model, which is nothing but a 0-1 ILP model. That means the LP solution is always an upper bound in the case of maximization problem. In the case of minimization problem, lower bound. So in this case, it's a minimization problem. They solved every problem as an LP problem. Then they taken that as a lower bound. For large scale problem, they compared it. Okay, just the procedure wise, I'm just telling you. Okay. So what is that one? This particular problem, Bunny-Owen scheduling problem, there are two interrelated decisions you need to talk about it. There are n jobs are waiting in front of the Bunny-Owen. First, you need to group the jobs into various batches. Multiple batches, you need to develop it. How do I develop the multiple batches? What are the constraints coming into that one? If I want to club to 2-3 jobs, is always after clubbing as a batch, then I have to compare with whether the batch capacity is violated or not. Once if I'm able to get 10 jobs into say 3 or 4 batches, then all these 3 or 4 batches, then I have to sequence it. That means there are two decisions. First is grouping the jobs as a batches, then each batches I have to schedule it. In other words, schedule in the sense I have to sequence those grouped jobs as a batches. These are the two decisions I have to do that. So in that, the first one, grouping the jobs into batches, they used HNN. That means integrating the available greedy heuristic algorithm along with the ANN, they developed grouping the jobs and form a set of batches. After forming a set of batches, they followed some kind of standard procedure to sequence that one. That standard procedure always leads to optimal solutions. People have already proved mathematically also. That procedure, they followed it. The second method is a straightforward method taken from the literature. For grouping the jobs into batches only, they used HNN. That we are going to see that on how that HNN works afterwards. Okay, so I'll tell you this scheduling the batches, how they done it using the standard procedure, which always leads to the optimal solution. I can give you through the numerical problem. How this working mechanism of HNN? I'm giving the working mechanism in the conceptual manner. They've taken one of the popular heuristic already published and claimed as a good heuristic in a greedy manner. That is called first fit longest processing time. It's very easy to follow that one. It's not a very difficult one. If you're having a 10 jobs, okay, and each jobs have a different processing time, order those jobs in terms of the longest processing time as a first, second longest processing second. Like that, you can order the jobs. Then take first fit. Take the first job on the list, on the topmost jobs, put it in a batch one. If it is accommodating inside the batch one. If it is not accommodating because of the batch capacity constraint, go to the second batch, second job, third jobs, like that. It's a very simple, straightforward, I can demonstrate. Okay. Then in the, that's why the decreasing order of their processing time, then you can fit that one. In each and every iterations, you are trying to form a batch. If you are having a n jobs, okay, and easiest one is how many batches are required. First of all, you don't know anything about it. If I'm having n jobs, I don't know whether I have a two batches are sufficient, 3 batches are sufficient, 10 batches are sufficient. We are not sure about it. Easiest assumption is each job can be one batch. That means given a problem to control it, I can define n jobs mean n batches. But you may not use all the n batches. Most of the batches will be empty. Only few batches you will be forming. Okay, that also will be achieved through this method. So every in the FFLPT, or first fit longest processing time, every jobs are given equal importance, because as per the data, if you remember, processing times are given and then job sizes are given. They themselves, they are not given any importance at that one. So I just take every job is importance, except that one longest processing time is important to me. The logic also there why I'm supposed to take longest processing time and first put it in the batch so that waiting time can be automatically reduced. The delay can be automatically reduced. Inventory cost also automatically reduced. So LPT always work. Longest processing time always is a good criteria to decide which job I'm supposed to schedule it first. But when I'm introducing the ANN, what the ANN does, for each and every jobs, it generates some kind of weights. It generates some kind of arbitrarily some weights, but following some systematic procedure. Those weights are used along with the FFLPT, and then that is integrated one. Then it goes into the kind of hybrid hybrid neural network. That means if it's called epochs, there are multiple epochs are used. How many epochs you are supposed to use it in the artificial neural network, that is also supposed to be an exercise. How they done it also I will explain to you. So I'll just explain this entire mechanism through a simple numerical problem, the same numerical problem I'm taken. The first epoch 1 or the first run 1, we call it in the simulation language. Okay, your HNN is hybrid neural networks exactly like FFLPT only, because I'm assuming every job as having a weight like equal to 1, equal to 1, equal to 1. So with that, now how that FFLPT works, entire jobs, 10 jobs I have to scan through. Whichever the job has the highest processing time, I can place it in the batch 1. So job 10 has the highest processing time and put it in batch 1. Then remaining 9 jobs, again, I have to scan through whichever the job has the highest processing time and it occurs as a first occurrence. So job 2 is the highest processing, it is occurring in the first time. And then I'm putting in the job 2. And then every time placing into the batch 1, I have to check whether my batch capacity constraint is getting violated or not. Because batch capacity is 10, job 10 is only 1 board is required, job 2 is required 3 boards, only 4 boards are consumed in the batch 1, still I can go for 6 more boards. That means again I have to scan through this entire list. Then I can put job 5, which has 11 as the highest processing time. Okay, that time it is 5 is a number of boards required. So almost we have finished 90% of the capacity of the batch capacities. Still I can find for 1 board anything is possible. Then again, if I go to highest process time, job 6 is highest process time, but I cannot place it inside because it requires 5 boards. If I put it, it becomes a 14 board. It's violating the capacity constraint. Next, I can go to the job 7, 10. That also I cannot go. Sorry, job 1 is the next first occurrence. I cannot go there because it exceeds the capacity. Like that, if I scan through, then only thing job 9 I can put it, even though it's a processing time is 1, because my objective is to fully utilize the capacity of the Banino one. So I have taken job 8, the 10. Just only job batch 1 goes job 10, job 2, job 5, job 8. These are the 4 jobs goes into the batch 1 with the capacity of 100%. The processing time maximum of 12, 11, 11, 9, 12. Like that, this remaining batch also gets formed. I just put it in the numerical problem like that. Batch 1 is formed, batch 2 is formed, batch 3 is formed, batch 4 is formed. All the batches are formed. And with respect to each of these batches, I calculate the processing time also 12, 11, 8, 1. And number of jobs which are processed in batch 1 is also I have taken this one because this is required. Already theory says that one, if you, now once if I form a batches, each batch I can call as a single job. Or you can call it a single job, okay? There are 4 jobs are there. That is B1 is one job, B2 is another job, B3 is another job, B4 is another job. You can call it in a different terminology, right? So which batch I have to supposed to put it in the Banino one first? What they say that one, weighted shortest processing time supposed to be placed inside first. Once if you do that one, it always leads to optimal solution. People already proved it. How do I get a weighted shortest processing time? The 12 is a processing time, 11 is a processing time, 8 is a processing time, 1 is a processing time. If I just take only the shortest processing time as a first criteria, I can put B4 is a first, and B3 is a second, and B2 is a third, and B1 is a fourth, I can put it. But that there is no guarantee for getting a optimal solution. But I can put some means weighted processing time. The weighted processing time, I can easily do that one. What is the weighted? I can take it processing time divided by 4, or for every job, what is the process time takes. For every job, what is the processing time takes. For every job, what is the process time. That is called the weighted processing time. That always leads to optimal solutions. The second decisions, how do I sequence it? That is the theorem that people have used it. So this, say if you do, so I'm in the meeting, sir. So this is the 4 jobs. We have scheduled it. B4 is the first, B1 is the second, B2 is the third batch, B3 is the 4th batch. In this order, if you do that, Batch processing time, it takes one hour. Assume that one starts with 0 hour. At 1 hour it takes. In the end of 1 hour it completed. The second batch takes 12 hours. 1 plus 12, 13 hours gets completed. Third batch starts with the third batch starts with the 13 hours. It requires 11 hours. That means 13 plus 11, 24 hours it gets completed. In the end of 24 hours, last batch starts and ends with the 32. This is called total completion times. This is a simple FFLPT. But what happens if I'm going for second epoch? In the second epoch, I want to find out importance of these jobs. Originally, all the 10 jobs are given equal importance. But the beauty of artificial neural network integrating with this FFLPT is it gives the different weights. How many different weights we can give it? That is also again decided in terms of number of epochs. Okay. So this is in the second onwards, this FFLPT always works along with the ANN integrated perspectives. I'll tell you, for that you need to have some kind of weight. How do I get this weight? I have to follow some kind of learning strategies where there are various mechanisms are there for learning strategies. These people have used backpropagations as a kind of methods. Okay. So the weights in the whole problems, instead of searching the solution space to get a good solutions, this entire HNN works for searching a good combination of weights for every jobs. That's why it's what best weight vector in the weight space. There is a weight space is available. You have to fetch some kind of appropriate weight combinations. That weight combinations will lead to a good optimal solution or near optimal solutions. Okay, weights are modified once at the end of each and every epoch. Okay, when that first epoch will be over, all the 10 jobs are formed into one batch. So set of batches. Those set of batches are scheduled, and then assume that what's the total completion time is uptime. Till that time, it's called epoch 1. That means if you are having 10 jobs, 10 iteration will go with respect to each and every epoch. Okay. Assuming that 10 batches can be formed. Why 10 iterations are there? Assume that each jobs can go to one batch. That means 10 iteration I'm supposed to do it. Then I'll end with that epoch 1. But generally, we don't want to go for 10 iterations. Once all the jobs are over, sometimes the program when you are writing, you have to provide the provision for 10 iteration. Otherwise, once all the jobs are over, you can stop it. So like that, how many epochs we can do that one, everything we can find it out. And also, whenever you are going from one epoch to another epoch, whatever the solution you are getting, you are always comparing with some kind of benchmark procedures. Here, benchmark procedure is always taken for large scale problem as a lower bound. The difference between the lower bound and this integrated procedure, whatever the solution gives, that is called the deviation or error, you can call it. It's true sense, it cannot be an error, it's a deviation from the lower bound solutions. But in the terminology that people use the error term. So the error they calculate, the deviation between the HNN solution with respect to the lower bound. If it is very high, the high is also the quantified. How it is in terms of high also they defined it. If it is very high, they change that weight again. Okay, if it is acceptable level, then the whatever the weight they take and they preserve it, because the same weight they have to come back as a back propagations. Because like that they do some 100 iterations, the 100 epochs, then whatever the combinations given that very good solution, they will come back as a back propagations. Okay, so that's what we have given. This is how they assign this weight as a learning procedures. There is a standard paper is there. They use that particular paper. I have not given the citation. This is the weight finding with respect to each and every combination of the jobs. They calculate the weight, and for that they use this kind of learning strategy like learning rate and this error also gap between the obtained solution and lower bound. In this case, obtained solution from HNN. Then there is uniform random numbers between 0 to 1 and everything they have defined it. How they define it also, they use some kind of methods. I can explain you in the next slide. Okay, and also sometimes they use the reinforcement and backtracking mechanisms are applied because that time you'll get a good combination of the weights. So how do they get it? Again, they have a modified weight calculations in this particular papers. Again, they used again from the earlier research studies. Okay, see now second iteration, assume that one they have not given any weight using that learning strategy and weight whatever the model they used it. This is the second iteration, they got the weight for each and every jobs. So once after getting that weight, what this FFLPT does, simply it is nothing but processing time into weight they multiply, then afterwards that they will put it in the decreasing order. So from second step epoch onwards, after getting the ANN gives the weight, that weight is multiplied with the processing time. That time your FFLPT becomes weighted FFLPT. How do I get the weight? Using ANN. That's in that perspective, it is integrated. Okay. And this weight also, once if I integrate it, multiply and then get some kind of highest weight supposed to be given a priority for that one as a first batch, sorting in the decreasing order of this weighted processing time into this weight. Is same algorithms. Only thing, initially we have taken as it is the processing time values. In the second iteration, second epoch onwards, you have to multiply with the weights arrived or derived from the ANN, multiply with respect to each and every processing time. Then after multiplying the things, you again sort it from the highest weight to the lowest weight. Then FFLPTO procedure still works. So in this second epoch, similarly they have done it after multiplying the things, and then they sequence that one. Then we got a TCT equal to 35. If the TCT 35, we need total completion time. We need to compare with the lower bound. Lower bound is 25. The 35 minus 25 is 10. If it is high or low, that is also defined in these problems. Then accordingly we can accept this weight or not. Then we can go for other weight. If it is acceptable one, then preserve the weight. Because whatever is acceptable deviation is that preserve the weight and go over number of iterations. I don't want to use the word iteration, number of epochs. Then they will come back, and then whichever the combination of the weights gives them the best or near optimal solution, we can choose that. How do they select this neural network parameters? That is one of the important in any neural network, because what are the important parameters? How many epochs you have to go for it? And then what is the learning rate you have to define, alpha equal to some values you have to define, and initial weights you need to define, and then reinforcement factor. How do they define this one? So one is, so in our case, we have taken as it is the paper, whatever this paper used it, we have taken, because our paper is extension to this paper. We have not done any explicit simulation to decide ideal values for all these four factors, or all these four important parameters with respect to neural network. Whereas these people followed Taguchi method, and then using Taguchi method, they arrived this appropriate values, or the efficient parameter setting values for these four parameters they identified. Taguchi is one of the advantages instead of going for complete factorial designs. Otherwise, somebody wants to get appropriate value for these four parameters, you need to follow some kind of factorial designs approach, and then you need to arrive it. But that is not required, because people have claimed that one Taguchi method, which gives the less combination of these factorial designs, still it reaches that complete factorial design format. Okay, that's why they decided all these four parameters values. Okay, we also use the same thing. Then you need to have a stopping condition, right? Somewhere you need to stopping conditions. Here they use appropriate stopping conditions. We also follow the same thing in that. Okay, so in this research they use 100 epochs. Because if you see that one, 100 epochs, how do they decide it? Just give this diagram, gives you some ideas. Each and every jobs, they are calculating different weights in every epochs. Each and every jobs, they are calculating different weights. So from the first epochs to the last epochs, you can see that one. After 75th epoch onwards, the weights are not changing at all with respect to every jobs. The highest weight was getting one particular jobs, it remains the highest weight. Okay, the next highest job was getting another job, that becomes the next highest weight. You can see the stability as stable, it becomes stable. That means after 75th epoch onwards, it becomes stable. So automatically, then we can say 100 epoch is sufficient. Even in this case, 76, 77, also 100 sufficient, but we made it to go up to 100. And then using the back propagation, which is related to this corresponding 74th epoch, whatever the weight was assigned with respect to each and every jobs, those weights we have taken and multiply along with the processing time, then apply FFLPT, and whatever the solution we are getting, that's supposed to be near optimal solution in comparison with the lower bound. That's what we decided. This model also, this procedure also decides. Okay. Just now I can give you that your architect, how it works in terms of your HNN. Somebody, maybe a lot of computer science people are there, information science people are, so mathematics people may be interested to know that one. Here I just quick, because number of slides will be running plenty. I give quickly. So you know that one in ANN language, artificial neural network language, there are input layer, there are hidden layers. Right? Here input layer is a job layers and hidden layer is batch layers. And what is the purpose of each of these layer? Also, I just given this one. In the input layer, job layer receives an input signal, okay, from initial node. Okay, this is the job layer is a input layer, and batch layer is a hidden layers. Okay, initial node gives the signal to the job layer. Okay, and final nodes decides whatever the jobs are assigned to that. So this is the signal as coming to the job layer. Okay, each jobs gives the signal to the batch layer. You can say that one. Jobs are assigned receives an input signal from the job nodes are connected to the node of the batch nodes. So what is the job layer role? Next one is it connects to the batch layers. That means job 1 can go to batch 1, or job 1 can to batch 2, or job 1 can to batch n. But which batch it goes, again, that procedure will tell you. But this is the connectivity as in the case of HNN, sorry, ANN. Okay. Then each of these jobs, once if you decide, I have scheduled it, then it will give you the communication to the final node. Okay. Once the batch 1 is not in a position to accommodate a particular jobs, it gives the signal to the batch 2, please open your batch. I'm going to put another jobs. It will first takes only the, with respect to batch 1, what are the jobs are going inside to the batch 1. Particular job, you have fetched that one, but it's not possible to put it inside because of the constraints associated with the batch capacity. Then it gives a signal to the batch 2, please open your batch. If that job goes to batch 2. The advantage of this particular procedure is it does parallelly. Whereas if I do only FFLPT, it does only in a sequence element. Every batch it constructs, then only it goes to the second batch. Whereas since I'm integrating, I'm parallelly operating multiple batches. That is another advantage of using this integration of FFLPT along with the artificial neural network. So I'll just give you these numbers now. Anyway, this architects, the whole architects, you must be knowing that one. So I just put that one in the first iterations. There are 3 functions we need to define with respect to every iterations. What is the input function? What is the activation function? What is the output functions? This is always related to forming a batch for a given set of jobs. So I'll just show you the one particular things. This is the first iterations. Iteration 1, I've taken all the 10 jobs. First job has a 10 processing, process time is a 10 is the process time for the first jobs, 11 is the process time for the second jobs, and the last job is a 12. As it is, I've taken, the weight is taken as equal to 1, 1, 1, 1. Your alpha value is also 1, I've taken as a kind of learning strategies, okay? In the whole exercise, alpha learning strategies, that in alpha is factor is taken as a 1. Okay, the first one is always we are taken. That means as per the procedure, what I have to do that one, where is the highest processing time, it goes to that particular batch. These all the things. This is 12 is the 10th job is the highest one. Right now, nothing has been assigned to any batch. That's why 0, 0. These are all working mechanisms. No need to bother about it. Okay. So this just to feel on that, we have prepared a PowerPoint under this first 10th jobs only we are going to assign it. I'll just put it. 10th job is decided and communication has given to the final node. Yes, I've constructed the batch 1. Which job goes also it has to come. Then accordingly that communication comes. The 10th job is going to the batch 1. Okay. Then the 10th job is assigned. Now I'm putting as a equal to 1. That means I'm making as assignment matrix internally. That assignment matrix I can go and put as a 1 as a value, all other things as a zeros. I'll just complete this one because already time is up. Okay. And I'm also giving that one. Batch 1 is only operationally operative. The batch 2 is not operative. Once if I put 1 here, I'll say that hey, I've selected a job. I'm not in a position to batch 1. I'm not able to put 1 batch 1. So I'm going to open the batch 2. That time this 0 becomes 1. So automatically that is becomes 1. So now the job 10 is also goes as an output node and communicates that one. Then the same thing communicated back to the initial stage also. So like that we can form this assignment matrix internally. You have to form it. Job 10 is assigned in batch 1. So whenever you are assigning this 10 by 10 matrix always will be there because 10 jobs are there and 10 batches can be assigned. Okay. So that's what we have done it. So just this entire procedure works like that. I'll just give you that one particular scripts, one iteration. I can go all the 10 iterations. Okay. Now first batch is getting over. Okay. Just this particular place, I'll stop it. Okay. See now 3 jobs are placed in the batch 1 and it takes another batch and it tries to find it out whether it can fit it to that one. It says that when it's not possible to fit it, and that's why it is job 6 is going to batch 2. It cannot fit into the first batch. So it gives a signal to the batch 2 and says, this please open that one. Parallelly, it gets batch getting formed. Whereas if I use only FFLPT alone, parallel processing is not possible. Only sequentially it does. Okay, now there's batch 2 also open. Now onwards, whatever the job I'm fetching, either it may go to the batch 1 or it may go to batch 2. Simultaneously it does. So the batch, see now batch 2 only it gets filled it up. Job 6, job 1, still job 1 is not, the batch 1 is not completed. I just give you quickly that procedures. Okay. Job 7. I'll just stop when the batch 1 is completed. Now batch 1 is completed, now completely completed because the capacity is equal to 10. So like that we can do this. We need to do many number of times till all the chunk jobs are getting completed. 10 iteration, if you go, all the jobs are getting completed because your 10 jobs are there, 10 iteration you have to go. Okay, 10 iterations are over. Now all the batches are getting formed. So whatever the solution I've already shown, the same thing you can get it here. These are the solutions. In the first one, it's exactly works like FFLPT because your weight is equal to 1 and alpha learning rate is also equal to 1. Alpha learning rate is always for every time it's 1 only. The second one, I'm not going for completely. This is the weight formula is given, the weight is obtained that one. And this iteration 1, epoch 2. Now this is second epoch we are coming. And then now we are calculating that using the weight we are calculated. 10 into 1.47, alpha rate is 1. For everything we are calculating the weight, we are multiplying. Now with this, the same procedure goes. Number of times I have to run that one. I'm not proving that one. I'm just coming to the end of the results. Okay, straight away I come to the end of the results. The assignment matrix form. There are 4 batches formed. Correspondingly, we got these results. Okay. Okay, now the working mechanism, you know that one. How do I go and evaluate means? Can I take another 5 minutes, madam? It's already over. Over another just 2 minutes. So now I have to evaluate my proposed hybrid neural network. So for that, I need test data. Test data is generated randomly, and then I can compare with the optimal solution for various small scale problem. Also, I can compare with the lower bound on various small scale, various large scale problems. And your performance measure is relative percentage deviations. What's the relative percentage deviations? HNN solution minus optimal solution divided by optimal solution tells me relative deviations. That I can multiply in terms of 100, then I can get relative percentage deviation. What is the deviation value is always 0 to 1. If it is tends to 0, your solution is good. In the case of comparing the optimal solutions, tends to 0, in the case of comparing the lower bound, it's always good. That's what the people have done it. That portion, please go through the paper. You cannot, if somebody is interested, you can do that one. How do I generate a test data? That means whatever the parameters required for the particular problem, important parameters, you need to define it. And then for each one, give a multiple levels. See, for example, he has taken N is important, number of jobs is important factors, and job process name is another important factor. Job size is another important factors. Job process time, job sizes are taken as uniform distributions because uniform distribution is a distribution which takes care of all kind of worst situation as well as the best situations in terms of getting the random values. Are highly high variance, it gives you that one, that takes care of it. So with that, I can stop it. The complete analysis, how they done it, you can see that paper. Okay. Yes, madam. If any question is required, I'm ready to answer it because I have not completed. My objective is to give how that procedure has been adopted for these prescriptive models. Though AIN is used for mostly for predictive models, but in this case, they used it for a prescriptive model. That means they're arriving the weights and then multiplying with the existing FFLPT. Only thing they're parallelly doing this process. I'm sorry, I exceeded the time. Extremely sorry.
No problem, sir. Thank you very much. It is always a pleasure to listen to you. And let me thank him for so many things. I have to actually thank him. One is we could partner with ORSI Bangalore chapter because of him. He happens to be the vice president for ORSI. So, sir, thanks for partnering with us. And one more thing for which I have to thank you is, sir, always you are there to extend your help and support whenever we plan to conduct any event or any program, or whenever I come to you for the updating my knowledge with respect to my research scholars. You have been always very, very supportive to us. I am extremely thankful to you. Maybe one particular day I would like to invite you for a talk, how to write papers, research papers and research proposals.
Okay.
That would be really good and motivating for most of our postgraduate and postgraduate students and as well as our research scholars. So on that note, sir, thank you very much for joining us today. You have taken out the time out of your busy schedule. I know that very much, but how much ever I say, I don't think I will be able to say enough thanks to you.
No,
thank you, sir, once again.
Anyway, thanks for your nice thanks and other things, but it's not required at all because first of all, we are friends. Okay. And we want to share our knowledge. First of all, we want to share our knowledge. There is no kind of any barrier is not with us. Anytime, not only you, any of our participants also approach for any help related to research at IAC. Anytime we are always available. Okay. No problem at all.
I would like to tell this to our students also, research scholars also, and faculty also. He is such an approachable person. Anytime you have any doubts or any kind of support you look for, you can always approach him with as as I'm able to.
Yeah. Only thing, I don't know whether I went very fast or something. I don't know how many of them followed or something. Not sure about it. But this paper is very easy to read. But since I've given some sufficient information, they can easily read and understand how that neural network has been used for scheduling. People can definitely read and follow it. I've given some kind of input. I think this will be easy for them to read that paper now.
Yeah. Thank
Absolutely,
you, sir.
sir.
Thank you so much.
Yes.
Yes, Vindhya, over to you, Vindhya.
Yeah. Thank you, ma'am. Thank you, sir, once again. Audience, any questions from your end? You can kindly ask, sir. Participants can now ask queries, if any, to sir.
So one thing I want to highlight you that most of the time our own people, most of the time this ANN is using only for predictive purpose, most of the time. Please make sure that one nowadays people are started to make use of it for prescriptive purpose also in various domains. I've come across now. One domain is scheduling. At least otherwise people goes always with ANN. There are some kind of the data, bifurcate the data into using for predicting something and then comparing with the whether the prediction is correct or not. Am I right? That's what most of the time people do that one. But today the advantage of ANN is plenty. So kind of under the umbrella of machine learning.
Thank you, sir. Thank you once again.
Okay.
Sir, I wanted to ask you, during this burn-in oven operation, the last stage in the semiconductor manufacturing, are there any security aspects that need to be taken care of? Are there any security challenges that need to be taken care of?
So security, what type of security? I don't know what you are asking. Hazardness or something, or do that?
No, not the hazardous challenges. The other one is with respect to the chip. With respect to the manufacturing aspects of the chip.
See, that's why the purpose of putting into the burn-in oven is to check whether the device is becoming infant mortality or not, or it's getting failure or not. They want to check it. For that only, they are giving up to some kind of temperature and they are giving thermal stress conditions. Okay. When they're doing that one, that main purpose is that it's also in the closed environment. Once if they put it inside the burn-in oven, you don't have any role on that. Only thing, what set of jobs you have to take it and put it inside, that is your role. Okay. So that decision on which set of jobs you want to take it and put it in the burn-in oven is a very, very, very important one. The rest of things, technically, technology will take care of it. How that processing is happening inside. Okay. The temperature is always maintained 150 degree. Okay. There is no variation in that. Okay. And the duration also, you already set it after 6 hours only. I want to open it. That's also we are doing. Internally, technically, what they are doing, that portion we are not doing anything about it. Whether 150 degree temperature is required, or can I go for 140 or 130, so that your energy optimization one can think about it. That part we are not doing as a kind of operation research person or industrial engineering persons. Probably that will be done as a technical aspects work in the case of semiconductor manufacturing, technological point of view.
Yeah.
Maybe I think I don't know whether your question is related to that or not.
Okay. I was pointing out to that.
That portion we are not doing as we are some management people or industrial engineering persons. We are worried about how do I use that optimally, that resources.
Correct.
Not optimizing this temperature time and then duration time, that we are not optimizing. That is a given input to us.
Okay.
Yes.
Got it. Thank you so much.
Okay.
Thank you once again, sir.
Okay, madam.
Moving on with the next session.
Okay, thank you.
Yeah, thank you, sir. Thank you. Yeah, as the second plenary session, we have with us Shri P.G. Bhatt, sir, founder and director, Pluma Knowledge and Solutions Private Limited. He'll be talking on census and sensibility. So to introduce P.G. Bhatt, sir, we have, I call upon Professor Chandrika from MCA department. Ma'am.
Yes, ma'am. Thank you, ma'am. Good morning, everyone. The job of introducing our plenary speaker for today's session is a great privilege for me. Speaker for the current session, Mr. P.G. Bhatt, was a commander in Indian Navy. He served as an officer in electrical branch of Indian Navy. And after retiring from Indian Navy, he is in software industry since 1996. He was involved in starting 5 organizations and was part of a couple of startup organizations as well. His areas of expertise include text mining, natural language processing, project management, setting up of new organizations and companies. Mr. Bhatt is also a visiting faculty at Documentation Research and Training Center of Indian Statistical Institute, Bangalore. And he is also a visiting faculty for master's program in National College, Bangalore. He's also associated with a couple of schools as member of governing council and academic advisor. Mr. Bhatt enjoys teaching in institutes and also as corporate trainer in software industry. It's our pleasure to have you with us today. On behalf of Dayanand Sagar College of Engineering, welcome you, sir, and I request you to start the session.
Thank you, Professor Chandrika. Am I audible to everyone?
Yes, sir.
Okay, lovely. Okay. To start with, thank you, the organizers of ICAAICM, for giving me this opportunity, wonderful opportunity to share some of my experience with data analytics for social good. I also thank Dr. Raghu Hudley, CMD of Objective Technologies, and Professor Karthik Hosnagara of Wharton School for giving some technical guidance in this task that I'm going to discuss today. Now, let us briefly refer back to what Professor Mathirajan talked about infant mortality of IC chips during the burn-in period.
Sorry, sir. Will you be sharing some PPT, sir? Or
no, I will soon share the notebook. No slides, no PPTs.
Sure, sir.
I will share the notebook. But this I'm just talking before I can start sharing something. I will definitely share. So reflecting on what Professor Mathirajan just mentioned, he talked about infant mortality of IC chips and the need for testing. Now, one of the cases, the famous bug that shocked the world in 1994, it is mentioned in many places, including the autobiography of Andrew Grove, who was the CMD or CEO of Intel then. So what happened? FDIV, or floating point division, had a problem in the Pentium chip, which was released in 1993. A person by name Thomas Nicely, he nicely brought out, he's a mathematician, he was a mathematician, and he noticed some inconsistencies in the calculations on 13 June 1994. And he could not, it took him a few months, say about 3-4 months, to tell, okay, it is exactly because of the Pentium chip, because in the system, Pentium chip was part of it. It could have been because of anything else. But later, when he reported, some insider from the Intel told him that the Intel was aware of this problem since May 94. So a few months after Intel knew the problem, mathematicians discovered this problem and narrowed down to the Intel chip and telling, okay, where is the problem like? It is a FDIV. And subsequent investigations found that the result returned by Pentium was off by about 61 parts per million. 61 parts per million was the error, means the error was so insignificant by ours, that is what we would say, but mathematicians won't accept that. Then ultimately Intel was forced, because a lot of pressure came from the industry, the competitors like IBM, they all put so much of pressure. And Intel acknowledged publicly that there was a problem with the floating point calculation in the Pentium chip, which they had released to the market, but claimed it was insignificant, not serious, and would not affect the users. But the users did not allow. They said, no, that is not acceptable. And ultimately, they offered to replace all the bad Pentium chips free of cost. A very few people came back. A small fraction of the users came back, but still, Intel lost $475 million in 1994, which would be equal to about $1,000 million in today's rate. And this is one small silly bug, as they say. And that is an example of there is an error kind of bug. The seriousness of error multiplies by the number of exposures, by the number of users. Like if there is one error in the story that I tell today, I say there are about 150 participants. So it is to be multiplied by 150 times because 150 of you have lost trust in what I speak. Now, public data, what is available, published by the governments of countries, for example, or any public data, can potentially be seen by 7.8 billion people of the world and can be used by as many. Yes, in fact, it would not be. But we have to take it as seriously as that. And we have to have the sense of obsessive concern for the data quality, obsessive compulsive data quality, we have to say. Now, what we are discussing today is about the statistics of census, the census data, the information that is publicly available on the census data. Now, Registrar General of Census Commissioner and Census Commissioner says these things in his website. It is the largest administrative and statistical exercise in the world. It is the most credible source of information on demography, economic activity, literacy and education, housing, etc., 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 etc. And he also says the only source of primary data at village, town, and ward level provides valuable information for planning, formation of policies for central and state governments, and widely used by national and international agencies, scholars, business people, etc., etc. On and on it goes. So I won't read the whole thing. You can go to the website and see what he's telling. One example. Another small example how this data is used by the Election Commission of India. He says in his website that the health of electoral roll may be judged by comparing three parameters referring to census reports: gender ratio, elector to population ratio, and age cohort wise elector information, telling that, okay, if I am X age, what percentage of people from X age are registered as voters? That is a very important activity to see if the electoral roll is updated or not, and accordingly focus their attention to such activities to make up this gap. Now, getting back, that is talking about the importance of accuracy of data that is published as a census report. The whole talk that I will take about 50 minutes now. The development environment is a Jupyter lab. I will use no slides. The IDE that I've used for solving this problem or investigating this problem, I will present it as it is. No slides. And it is an active document, active book. So what I will not show is that I've extracted data from the website of Census India, and I have done the minimal cleansing of it, taking only the rows and columns of interest for this analysis and minor corrections. So this effort has been very small compared to the effort that we have to put in various other things. Means the data of census report data is available as Excel spreadsheet and comma-separated value files. It is very convenient to use. In some cases, 85% of our effort is cleaning and formatting the data. In this case, it may be 2%, 3%, that's all. So I'm thankful for the good way, the nice way they have published the thing. What I can now do is that share some notebook. So I named this as Census and Sensibility, because Sense and Sensibility is a famous classic novel from Jane Austen. So the whole thing is available as Jupyter Lab notebook, Jupyter IPython notebooks, which are shared on my drive with organizers. And it can be run, the code that we are seeing here is also available in the shared subdirectory, shared directory. on Google Colab. So you can just run it. You do not need any environment in your machine. Anything that can access internet, you can use it and you can run whatever is being shown now. You can see it on your screen, even using a telephone, a smartphone. So I will not talk about the technology per se. It's all done using Python and Python data frames, pandas data frames. You can run through it if you want. So what we are seeing first is that find the age. So when we get some data, we also have got information about the age of population starting from age 0 to age 100 plus. And there is another category, age not stated. So to see the quality of the data, the exploration first goes with the quality of data, then we can see what we can derive out of it. So quality of data, the things that I'm looking for is the quality of age data, the population in particular age, starting from 0 to 100 plus. So to find the age demography of the population, after cleansing, let us see the distribution of population by age. So here is the code. I'm not running the code. Oh, I think it needs to be run. Fine. Or it's already run for that matter. So what we have here is that the information that I have gathered, I'm not running each and every code cell here because it will take time. So what I have got here, the information that I have ultimately gathered for the sake of analysis, there are 3,612 rows and the 7 columns that I have taken. There are some 50 odd columns in the report, but what I have taken the subset of it is like this. I got the information about the state. So 0 means it is India. The district and the area name. So at the highest level, it is the India, all over India, the total population which is reported there. And I've taken what percentage of the total population, in the sense starting from age 0 to age 100 plus. At age 0, the total population is this much. 2 crore 3,11,234. That becomes 0.84% of the total population of India. And here I have taken population percentage difference. That means what is the difference of this value with the previous value, this value with the previous value. That is something that is calculated. Why it is done, we will discuss. So this is taking the head, means the first 5 rows. I'm just taking random 5 rows so that we understand the structure better. When you take random 5 rows, I got this information about the state, the code for the state, like 25 for Daman and Diu, 10 would be for Karnataka, 30 for Goa, etc., etc. And its district, the area name, district I have not gone down to the district level. I have taken only at the state level right now. And for the age, how many total people are there for like Daman and Diu? Age 98, there are 10 people. And what percentage of population they form and the difference with the previous age. It will become clear. The purpose will become clear. Then I'm taking all India level information is available. So I have taken data frame for India, all India, and I'm telling state equals 0. That means I'm interested in India only. I'm not interested in the 36 states and union territories. And what is the age of total population? This is the age and the total population. Yeah, I get the information for 100 plus age I am getting here. And if you have to see this, yeah, there is some 2 crore, 2.1 crore, 2.3 crore, 2.6 crore. It is boring and painful to go through. But suddenly you see, I stopped here, 34, 35, 36. 34 is 1.4 crore. 35 is 2.8 crore. 36 again 1.6 crore. Now, how can we have a situation where at the age of 34, I got 1.4 crore. and 2.8 crore, twice as much in the age of 35. Can the population grow in that ratio? Is it possible? Similarly, look at 39, 40, 41. 1.1 crore, 2.8 crore, 1.1 crore. That means there are some spikes in some ages that we are seeing when we look at it randomly. But if I have to do it methodically, it is a painful work to look at the numbers. And now we are looking at the Indian level. Now, if you have to look at the state level and the district level, doing it manually or looking at the table is not convenient. And one very convenient way is look at the graph, visualize it. So when we visualize it, what we see is that at the all India level, the ages starting from 0 up to 100 plus, I find sudden spikes in some places. You can see all these spikes standing out. Now it helps us to see that at 30, 35, 40, 45, etc., there are sudden spikes. In the sense, the population here is so much higher than the population at an age 1 below and 1 higher. And also we find some spikes at some other place. For example, here, again, I have elaborated, which you have already seen, the population at 39, 40, 41, 1.1 crore, 2.8 crore, 1.1 crore, all over India. Now, what we are doing is that, one thing is that taking the total population. If you take the total population from the state to state, there is a big difference. Like if you compare the population of Puducherry with the population of Uttar Pradesh or Bihar, I cannot take the absolute number. What I have to do is I'm now interested, rather we have narrowed down that we are interested in the spikes. And this spike as a percentage population helps us to compare state to state, telling that where do we have more spikes compared to the previous. So that is what we have done, is that some calculation that are available here and stored. So what we are seeing is that the spikes are seen in so many districts, out of the total 640 odd districts, are seen at the age of 8, age of 10, age of 18, 20. So these are the ages at which we find maximum number of districts find spikes. I'm not here telling absolute amount, where the spike is more than 0.5%. So we find that, again, we find that 20, 30, 35, 40, 45, 50, 55, 60, 65, 70, they stand out. So what we can surmise here is that there is a tendency to round off the age, ending with 0 and 5. It's a common thing. Yeah, we find that. So 0 and 5, at which more than 100 districts show population spikes. And we also find at some other ages, like ending with 18, ending with 28, ending with 38, there is sudden spikes of the population. In the sense, at the age 28, in 419 districts, the population percentage rise is more than 0.5 compared to the age 27. So here we find in a table, like say at the age 18, 324 districts show spike, age 28, 419 show, etc., etc. So what we have done is that this population variation, population percentage variation by age all over India, again we have plotted here 10. We have highlighted. What we have done here is the absolute ages. Now this one, what we have done for the sake of demonstration, easy to understand, we have highlighted ones where it is more than 0.2. You could have chosen 0.5, then okay, these are the ages where we find sudden spikes, which is very clear, 30, 40, 50, etc., etc. So this is at the all India level. If it is at the all India level, that will give us an idea, okay, there is an action that the age spikes are found, and now do something. At the all India level, with the kind of population, we have got 1.3 billion people, how do we say, where should I focus? Now we have gone down to the all India level, the percentage of total population where it is spiking by more than 0.5% compared to the previous age, they are highlighted. Rest is not highlighted. You can see the variation here to here is smooth, not as significant as this much. We have chosen 0.5 value here. It could have been 0.2, 0.8, whatever we can choose. Now, if you come to Jammu and Kashmir, it is different. Himachal Pradesh, you can see the spikes are less. Punjab, Chandigarh is far better. Uttarakhand, Haryana, Delhi, the lower ages we don't find, the higher ages we find. Rajasthan, Uttar Pradesh, you can find the quality of age reported is perpetually showing a bad result. Look at Sikkim, there is no spike at all, more than 0.5. Arunachal Pradesh, on and on again. Suddenly we say Mizoram, there's some strange thing has happened. Jharkhand, Orissa. So for each state, okay, suddenly if we find some strange behavior here, the ages at 17 and below, there's a very low population here in Daman and Diu. This is another thing that we have to investigate. We can check why is it so happening. Here again, the same thing, Dadra and Nagar Haveli. Lakshadweep, Kerala. We have level. We can further do it for the district level. But this again is not something that is quantifiable. What I have shown here is visually which are the states where the spike is more than 0.5% compared with the previous one. Now, this is in general called age heaping. So we saw illogical spikes in certain ages, which is more prominent in certain states and certain districts. Now we want to quantify it. Is it possible to quantify? Is it something that is found everywhere? Is it only in the Census India that we are finding it? No. Age heaping is more prevalent in innumerate people, the people who do not know how to count or illiterate. We saw that in Kerala it is hardly any, and we saw that Bihar it is very high, UP it is very high. In some districts it's high, in some districts it's lower. So there may be a correlation between the education level and age heaping. And it is common around the world to round off this number to the nearest 5 or 10. And also it is mentioned in various literatures that the quality of age reporting can be measured by means of age heaping indices. And the most famous, the most popular, and the simplest one is called the Whipple's Index, which we will be using. So what is Whipple's Index doing is that the Whipple's Index, what we do is that take the ages 25, 30, 35, 40, up to 60. So the ages less than 23 and above 62 are excluded, thinking that, okay, they may not be evenly distributed, so our calculations will not give a proper result. So we're considering the ages between the ages 23 to 62, only that much is taken. And we take the select age of 25, 30, 35, 40, up to 60. And we also take the complete ages 23 to 62. So the total population in the 23, 24, 25, 26. And because you have taken every fifth age here, we multiply it by 5. So this age as shown divided with the total ages gives the Whipple's Index. It is as simple as that. So if the linearity assumption is true, 5 multiplied by this 5, 1/5 of the population, divided by the entire population will be equal to 1. So W should be, the Whipple's Index should be 1 if the distribution is linear. We know it is not going to be absolute linear. Not everyone from the age 23 to 60 population, the population at this age, 23, 24, 25, they are not going to be absolutely equal, but they are going to be approximately equal. Now, there is another thing called modified Whipple's Index. The Whipple's Index assumed the rounding off at the ages ending with 5 and 10. But we already found that in other ages also, like 18, there is a very holy age where somebody becomes eligible for driving license, becomes an adult, can vote in the country, and many other things, becomes an adult. So at age 18 may be a preferred age for people asking, okay, what is your age? They may round up to 18. Marriageable age for girls, legally, etc., etc. So the modified Whipple's index, instead of applying only for ages ending with 0 and 5, we take ages ending with 0, 1, 2, 3, 4, 5, up to 9, 0 to 9. All ages we take. And we divide, according to the formula is modified a little, so that we get Whipple's index for every age ending with 0 to ending with 9. That is the modified Whipple's index. I'm not going to discuss this, and it is very similar, very simple, very straightforward. So then for every age ending with 0 to 9, the Whipple's index should be 1 ideally. It will not be 1 because the distribution is not as linear as that, but it will be close to 1. Then we also take something overall summary. In all these ages put together, 0 to 9 put together, we get some Whipple's index, which may be 1 above 1 or minus, it can be 1 or minus 1. So what we do is that we take the overall summary, sum of absolute value of W minus 1 for W0 to W9 that we have discussed here. That gives the overall summary index, given the quality of age reporting in a particular area, say district or a state or the country as a whole. Now, there is some code here that is demonstrated, that is seen. So then we take some sample data. If you just take the total data is 676 rows and 15 columns, that is for the districts, for all the districts of the country, because district level reporting is the most granular level that we have got in the census report. At the district level, we know what is the age of people, how many people are in a particular age, what is the population there, and also the education level of the people by district we have got. Lower than district we do not have. Fortunately, we have got at the district level. The census report of many other countries that I have been trying to look at, they don't have this much of granular report. By every age, they don't. Many of them don't have. Education report wise, they don't have, and they got at the maybe the state level, not at the district level. So we are fortunate to have a deeper level of reporting. So here we have got at the district level, whatever we have got. Here is a sample report, a random sample that we have taken of 5 rows. What I have got from this Whipple's index, modified Whipple's index, and the total Whipple's index we have calculated, and we have put here. Now the state, it is randomly taken. That is, the indices are 25, 284, 105, 208, 107. It is a random sample. State, Andhra Pradesh, Madhya Pradesh, Bihar, Himachal, etc., etc. Now, the district number of that, because 676 districts are covered here, 552. Area name, that is the district name. 0 means at the state level, that is why you got 676, 640 plus 36. Rohtas, Bilaspur district, etc. And in the columns, you have got values for the Whipple's index for ages ending with 0, ending with 1 up to 9. And I also got the total absolute. This is the summary Whipple's index. That means this is the effect of the variation in the age reporting, or the spikes in the age reporting from ages ending with 0 to ages ending with 9 for the whole district of Kurnool of AP, which is 3.97. Now we know ideally it should have been 0. Ideal situation of this absolute index should have been 0. So when I say 3.97, it indicates us the quality of age reporting in the Kurnool district of Andhra Pradesh is 3.97. So it is not as good as the state of Madhya Pradesh, or not as good as Bilaspur district of Himachal Pradesh, where it is 1.14. So the lower, the nearer to 0, the better is the quality of age reporting by this index. Then what we have done, we have also seen, okay, we have to consider the ages, only at the ages ending. Now, if you want to compare is it better for females versus males, better for illiterate versus literate, better for rural versus urban, all that kind of separation, the division we have done. And then we have got sample like this. If you see here, the ages ending with 0 to 9, as we have seen already, urban, rural, etc., etc. So ultimately, we have got 58 columns, 676 rows. So we expanded the information into 58 columns, means for each district of each state of the country, I have got information of the Whipple's index, ages ending with 0 to 9, urban population, ages ending with 0 to 9, rural population ending with 0 to 9, the rural population same way, the illiterate same way, the educated same way, male and female. So we have expanded the table so that any kind of analysis based on these divisions are possible. Then if you find describe the major information that we are interested to see, the summary of the statistical information, we find the mean, standard deviation, minimum, maximum, 50 percentile, 25 percentile, 50, 75, and the maximum. So the total districts, as we saw, 676. And 471 of them are more than 3.37. That shows that our Whipple's index is fairly poor. The summary Whipple's index is fairly poor. The minimum is 0.46. Okay, close to 0. 50 percentile if you take 2.6, that also doesn't tell a good story. That is for the total. If you consider the quality for the females, the males, rural, urban. So it's a neat little summary. From here, it helps us to, okay, is there something alarming or not? Should I inspect something clearly? For example, here, if you see, for the maximum for the females, summary index is 5.35. For males, it is 6.15. That means the males are generally telling wrong ages. They are lying about the ages. They are rounding off more often than females. The rural, 5.47 as compared to the 5.0. So there is also an indication that the urban population is slightly better than rural, not far better. Or 75 percentile, if you see 3.6 compared to the 2.8, not all that better. Rural population is not that bad in reporting the ages. Then if you consider the age-wise Whipple's index, like we said here, we have got it for W0 to W10. So what does the Whipple's index say? Earlier we saw the total population, the percentage of population, the spikes thing. Now we are going more scientifically. We have quantified the quality of age reporting with the help of Whipple's index, which is one of the most popular. Here we find the Whipple's index is the highest for 0. So rounding off to 0 is most common. This is all India. You could see it for state by state, district by district. The next one is age ending with 5. That is something very clear. Now, in between, we find ages ending with 8. But we saw that ages ending with 8, not all of them. 18, 28, 38 seems to be the favorite ages. We don't know why. At least I do not know why, etc. So, but mainly it is very clear telling that ages ending with 5, ages ending with 0, as originally thought by Whipple, are rounded off very highly in India. Now let us say if this is true in India, how is it with other countries? I took USA. In USA, if you take the Whipple's index for the USA, ages ending with 0 to ages ending with 9, USA 1.03, 1.02, 1.09, 0.99 is the minimum. But in India, if you already seen 1.76, 1.66 for ages ending with 0 and 1.66. Now, if you draw the plots, here is how it looks. Let me. All right. You can see Whipple's index for ages in USA ending with 0 to 9, they're all close to 1. No problem. Supposed to be 1, ideally, for individual ages, the total index is expected to be 0, but the individual ones, as we discussed earlier, is supposed to be 5 ideal situation. That is fine here. And India, we have already seen, there's a comparison between the age quality calculated by the Whipple's index for USA and India. The summary Whipple's index, if you see, state by state, which is supposed to be expected to be 0, if it is ideal situation. Now this is how it varies for various states of the country. So here I put the names of the states in the x-axis, and total Whipple's index, or the summary Whipple's index, you can see Bihar is the highest. Uttar Pradesh, Jharkhand, Karnataka is no good. We are here, 3.0. Yeah, better than Bihar, but nowhere very good. You can see Lakshadweep here, pretty good. You can see Goa, larger state compared to Lakshadweep. You can see Kerala. So we see that the Whipple's index, or the quality of age reporting, differs widely across states. So when you know it is differing widely, then the Census Commission has got a reason to focus on the states where it is poor, rather than overall telling, okay, it's poor in India, now we have got a place that we can focus downward. Once we choose the state, we can also see district by district and focus on the district where it is highest. So this helps us to focus on the areas where the age quality, the quality of age reporting is poor. If you consider male versus female, so these are females and males, the Whipple's index goes like this. You can see the females are better when the blue is higher, males are better, sorry, when the blue is lower, and the males are better when the orange is lower. But there is no big difference. The females are slightly better in reporting accurate ages compared with the males. Not much of a difference. Similarly, if you consider the rural versus urban population, you can see the rural population, the index has always been high. And the urban population is better. Overall, if you consider, it's marginally better. And again, this helps us to compare, okay, where is it better? Andhra Pradesh, we can see that the reporting is far better in urban population and much poorer in the rural population. If you go for Sikkim, they are almost identical. Mizoram, almost identical. Karnataka, you can see rural is far worse than the urban. Goa, you can see they're almost equal, etc. So this helps us to say, if I have to focus the education of the enumerators to be more careful in the rural area or urban area or equally, this also will help us to see where to focus when you come to which particular state, and from there we can go down to the district level. Now let us see the effect of illiteracy on the age reporting quality, effect of sex in the male versus female, urban versus poor. Is there any correlation between these two things, which is generally called regression? The correlation count can be seen. So there is an independent variable on the x-axis. Let us consider the females. And y-axis, we have got the quality of age reporting. So does it mean that the higher the population of females, higher the quality of age reporting, lower the quality of age reporting, or is it neutral? If one independent variable has got an effect on a dependent variable, then we say there is a correlation. If there is none, we say it is neutral. And if it is positively affecting, it is a positive correlation, otherwise it is a negative correlation. And the quantifying of this characteristic is done by the covariance count. The formula is available. And the Pearson's correlation, further to that. I'm not discussing these things. This notebook is available for all of you to download from the shared notebook, or the coordinators of this event can share it with you, or they can forward it to you. It's not much. And I hope it will be easily understandable. Now what we have done is, we have drawn some plots. Illiteracy rate is higher in the rural India. Like you can see, here we have got the state, district, area name, the total index, female, male, etc., that we are repeating. And what we have added to that, what we had seen earlier, this is something that we have seen earlier in the notebook. What you have now done is that we have merged the information from another table that is available with the census report, the illiteracy percentage. I have not taken, okay, how many are just literates, how many are matriculates, how many are graduates, how many are postgraduate. That detail I have not considered, which can be done going deeper. Right now we are telling illiterate percentage. Anybody who claims to be literate, we are not considered. So the illiteracy percentage, 31.24, 25.49, etc., are added to the other indices that we have already calculated by merging the data. Similarly, the male-female information we have merged, and we have drawn some plots. Now this is the regression plot. What you have seen here is the male population percentage in district in the y-axis. Sorry, x-axis. The y-axis has got the Whipple's index. It's a bubble plot. And the trend is shown by this line. And the shaded area shows the fuzziness. It could be here or here. So that means when the male population increases, the Whipple's index increases. Means the data quality goes down. Higher the Whipple's index, poorer the data quality. So we see that from little higher than 2 and little less than 4 is the line connecting, the trend line connecting the values of the total Whipple's index. Means for all the ages ending with 0 to 9, the total Whipple's index for various populations, population percentage in districts. So here if you consider, here naturally, the histogram is covering for the male population, aged maximum naturally will be in this area. Above the higher ages will be lower, so it shows the distribution. And Whipple's index as a histogram is shown to the right. So this is a joint plot. So this anyway visually shows us that more males, poorer the quality of age data, but not very high. And if you consider the rural population percentage in district, every district like Bangalore, if you take, what is the percentage of rural population? Or Tumkur, if you take, what is the percentage of rural population? So again, the districts show that more of the population are rural. That is a known thing. And at higher ages. So that is how it shows based on the counts that we have got. Here, this is showing illiteracy rate in the district versus the Whipple's index. Here you can see a very sharp increase in the Whipple's index. As the illiteracy rate increases, there's a much sharper increase in the Whipple's index. Means there is a very high correlation. There is a reason to think that if the education is better, the Whipple's index would improve. In the sense, the Whipple's index will come down, the quality of age reporting will improve. Clear from this visualization. Again, illiteracy rate Is it higher in the rural population? Yes. Now the quality, quantifying the correlation. Here we have visualized the correlation. Now if you quantify the correlation, what we find is age heap correlation with the male population, 0.11. Not very high, but indicative of minor change. Age heap correlation with the rural population, 0.4. Means supposed to be 0, the total summary index. Now if it is 0.4, that means it is close to 0.5 where we have to start paying attention. But illiteracy rate correlation with the rural population is 0.56. So this already subsumes this factor. Means if you are rural, you are also less educated, less literate, and your correlation also is higher. So we can take these two into account. Age heap correlation with the illiteracy rate is 0.68, which is a very clear indication that the education matters, the numeracy matters, the literacy matters to get the correct age. So here again we have got the same thing done. So what we have seen is that the summary of finding is that lower education level shows a correlation of 0.67 with the age heaping. Illiteracy rate is higher in rural India with a correlation of 0.55. Therefore, higher age heaping in the rural India may be due to lower education already reflected in 0.1. Correlation between the sex of the population and the age heaping is weak, approximating it to neutral. So this is a summary of finding. We can see one of the example effect of age heaping. Fine, we have reported a wrong age. Then what? So what? In the beginning, we said the claims of Census India telling that how its findings affect everything in the world. Well, okay, everything in India at least. And let us see an example of age heaping. Now, the Election Commission of India says that we have to continuously do a gender ratio check. Like what is it in Kerala, what it is in Himachal Pradesh, what is in Haryana. We have to compare with the report from the census. Electoral to population ratio, you have to say, okay, how well is the registration? How many percentage, what percentage of people have registered as voters? That has to be taken for the electoral to population. Of specific ages, like the ages 18, ages 19, ages 25, ages 95. So for that, they say age cohort-wise electoral information should be calculated, and they claim to have calculated continuously. That is another beauty of inaccurate reporting by various government agencies. Now, say voters aged 30 in the electoral roll are this much, 2,24,554. Population aged 21 in 2011 who would be 30 in 2020, because these voters aged 30 are as calculated in 2020 is 1,98,514. This is from the census report. Now we find there are more voters than the population who have grown from the age of 21 to 30 by the 2020 by this year. But then this gap may be and is explained by the large amount of migration that happens. Apart from the people who are 21 in 2011 who become 30, there are so many others who migrated since 2011 to Bangalore, and they increase the count of electors. That is fine, indicative, fine, good enough. Voters aged 18 is only 8,443. I'm talking only of Bangalore, not all over India or all over Karnataka. And in Bangalore, the population aged 9 in 2011, who would become 18 now, is 1,38,000. So it's a very clear indication telling that people who are 18 as per census, excluding the migration, a very small percentage of them are registered as voters. Now, there are two aspects here. One, we have seen a hike, we have seen a spike or age heaping at the age of 18. Now, how much can we rely on this? So there is an error that is happening here. Now, if you compare various other things that we have compared, what we have done is that we have taken the population percentage, voter percentage, adjusting for this age, means whatever was population of 9 years, we have taken it to be the population of 18 years now, and we have taken the voter percentage. So you got the population percentage, voter percentage, absolute population, absolute voters for the Bangalore for all the ages starting from 18 up to 100 plus. So adjusting for this lapse of 9 years, if you plot, we find the Bangalore voters and the electors and the population by age. The blue curve is for the age. We can keep seeing these hikes or the age heaping. And in the voter, we do not find. And this gap we see. Now, this age cohort calculation is not possible. And even if they claim that they have done, it is erroneous. And if they claim it to be correct, it is erroneous. Similarly, we can see the percentage, the previous one, absolute number, the percentage gives similar number. If you plot a bar graph that gives another view, gives a similar number. So that is what we have. So what we can see is that here, if you see the Bangalore voters by age, there is no age heaping. There is no sudden spike. The distribution is fine. We do understand that less number of people have registered here and maximum number of registered voters are in the age group of this one, that we find. But sudden spike we do not find. We know one thing, that during the voter registration, we have to give an age proof. During the enumeration for census, there is no age proof required. Whatever the age you mention, or any proxy, your family members or neighbors mention, that is to be taken. And it is very clear in the site of ECI telling that enumerators are not authorized to ask for age proof. Very small thing. Wherever else you go, you need to give age proof. You open a bank account, you join a school, you become a voter, you go for the driving license. Wherever you go, Aadhaar card is needed, the age proof is needed. Why do we exclude the age proof from the census report? And arrive at a situation like this, having such shameful situation of age quality, and again, not give it as a support. You see that one small error, small bug in Intel Pentium chip, what it has costed them $100 million of loss. Now here we have got a rampant error and we are not taking care of that. So what recommendation we have? A pilot study of select districts should be conducted to evaluate the quality of data and the effectiveness of their applications that they use. Lessons learned from various other studies conducted, like the Election Commission. Lessons learned by our government agencies. Innovative methods. There are so many things that we can suggest to improve using technology. Enumerators may be provided with the citizens' data which they already have and compared with the data they are providing orally. And total index of age heaping is calculated for each district and the enumerators can go with that data, etc., etc. The whole thing that I have told here, not the notebook, not the Python code, is summarized in my blog here. I invite you to read the blog. I'll be glad to work with the people on use of software technology for social causes, not only this census. I'm not doing so much work here. I do a lot of work with the electoral roll. It's my name, email ID, phone number, and I'm running out of time. I'll be very glad to answer any questions. Thank you.
Thank you, sir. Thank you for this very informative session on analysis of census data. It has been, you have given some good insights on how census data can be analyzed for some real end-use end applications. I'm sure, I mean, the one application that immediately comes to my mind is smart city development or smart city analysis. So the excerpts from these can be taken as inputs to that kind of study, and that definitely, the presentation was, you directly shared the implementation and ran through the details of the implementation that was different, but well taken definitely by the audience, I'm sure. Also, sir has been kind enough to share this Python code with us. He has already shared the link with the organizers. So we will be sharing that with the interested participants for sure. So those who are interested can definitely contact the organizers. Thank you again, sir, for that. Audience can now ask their queries, if any. Any questions from the audience? Okay. So thank you very much, sir, for your time. And sir has been here with us for yesterday's sessions and today's. We thank you very much for your time and giving us details on the census data. Thank you so much, sir.
Thank you very much. Thank you very much. Kind of you.
That was the last technical talk, the second plenary session for the day. We can take a break now for lunch till 2 p.m. and 2 p.m. onwards the tracks start. So I request all the authors, co-authors to kindly join the tracks through the links that's already shared with them. I request you to join there a few minutes ahead of the schedule so that it's for everybody's convenience. So tomorrow's sessions, we will be again here with the 3 technical talks for tomorrow, starting 10 a.m. We'll be having talk by Mr. Victor Sundarraj, Head Engineering Academy, Infosys Limited, Bangalore, and he'll be talking on the role of AI in live enterprise. After that, at 11 a.m., we have another plenary session by Ms. Vandana Verma. She is a Solution Security Architect, IBM India, and she'll be talking on emergence and relevance of cybersecurity with AI. The last plenary session will be given by Dr. Krishna Chandra Gowda. He's a senior scientist, CSIR, Bangalore, and he'll be talking on applications of artificial intelligence and machine learning in applied science. So we have 3 interesting topics lined up for tomorrow. I request all of you to join for the sessions at 9:45 a.m. 10 o'clock the talk begins. So kindly join to your regular track presentation tracks at 2 o'clock. All the authors and co-authors, I request all of them to be there on time so that we can start the session on time. Any queries can be taken through chat box or you can message us. Thank you and all the best for the presentation.